Imagine light that has never stopped moving, a journey that began nearly 14 billion years ago and has continued without pause. Some of the very photons born in the first fractions of a second after the Big Bang are still with us today. They travel endlessly, stretched and thinned by the expanding universe, until they reach us as faint signals, whispering across the cosmic background. If you close your eyes, you might picture these particles as ancient messengers, carrying fragments of the universe's earliest memory, fragments so faint that they can only be detected by instruments sensitive enough to register their delicate traces. These photons are what scientists call the cosmic microwave background. To the human eye they are invisible, but they fill every corner of the sky, a quiet glow from the birth of everything. Imagine a sky that never goes completely dark, even though our senses cannot perceive it. For the earliest civilizations, night seemed like pure absence, yet above them, these silent travelers were already washing over the earth, flowing through stone, water, and air, unnoticed. Their persistence is a reminder that time itself can be carried in waves, that memory is not only written in books or carved into stone, but embedded in the very light still moving past you as you breathe. Consider daily life in this light-filled universe. When you walk outside in the evening, you may think you are surrounded by darkness, but in truth you are walking through a sea of ancient radiation, photons that have passed effortlessly through centuries of human existence, through the rise of cities, the construction of temples, the everyday rituals of people who never knew such echoes existed. While empires rose and fell, the light continued. While generations lived and vanished, the photons passed quietly, brushing against faces that never suspected they were touched by the oldest signal in existence. There is something humbling about this constancy. The cosmic microwave background does not tell dramatic stories of battles or kings, yet it holds a narrative that dwarfs them all, the survival of light itself. And though these photons cannot speak in words, they tell us something profound, that beginnings do not vanish, that traces of creation linger, and that we, too, are always living inside echoes of a much older story. Imagine yourself sitting quietly, breathing in the stillness of your own room. Every breath you take carries atoms of oxygen, carbon, and nitrogen, tiny building blocks that were not created here on Earth, but in the hearts of stars that lived and died billions of years ago. The calcium in your bones, the iron in your blood, the carbon woven into every cell, all of it was forged in stellar furnaces. Stars are not just points of light in the night sky. They are ancient factories, where unimaginable heat and pressure fuse lighter elements into heavier ones. When those stars reach the end of their lives, they release their creations into the vastness of space, scattering them like seeds. Over time, these seeds gather, condense, and form new planets, oceans, and, eventually, living beings. You are, in the most literal sense, star-made. Think of daily life in an ancient civilization. Farmers tilling fields, children learning songs, rulers building monuments. None of them could have imagined that the dust beneath their feet and the air they breathed carried the history of stars that perished long before the earth had cooled. Today, you walk among streets, markets, or quiet libraries, still surrounded by that same cosmic inheritance. The rhythm of human lives continues, unaware yet deeply tied to processes far older than memory. And there is a paradox here. The stars that birthed your atoms are gone, and yet they remain alive in you. Their light no longer shines, but their essence continues in every heartbeat, every thought, every small gesture of existence. Imagine yourself looking up at the night sky, each faint glimmer reminding you not of distant strangers, but of the very matter that makes you possible. The atoms of your body are ancient travelers, carrying the quiet memory of stars that burned out eons ago, now resting in the quiet flow of your breath. Imagine standing at the edge of a cosmic shoreline, where gravity holds light itself captive. For decades, black holes were thought to be eternal prisons, swallowing everything with no escape. But in the 1970s, Stephen Hawking introduced a startling twist. Even the darkest objects in the universe are not forever. Through a subtle process called Hawking radiation, black holes release tiny amounts of energy, particle by particle, until, over unimaginable spans of time, they slowly fade away. It is not a dramatic explosion or sudden collapse, but a patient leaking, like a candle that burns so faintly you hardly notice the flame until it is gone. To picture this, imagine the quiet erosion of a stone by centuries of rainfall, or the way ink seeps from old parchment until the words almost disappear. The black hole, immense and seemingly indestructible, is gently undone by quantum fluctuations at its horizon. Pairs of virtual particles flicker into existence, and one escapes while the other falls inward. What was once thought to be a perfect seal against time instead reveals itself as porous, bleeding secrets into the emptiness around it. For stellar mass black holes, this fading is almost impossibly slow, stretching across timescales longer than the age of the universe itself. And yet, the principle holds: even the deepest wells of gravity cannot resist entropy. A black hole that once devoured stars and bent space will, eventually, dissolve into silence. It is a reminder that permanence is an illusion, that even the universe's strongest locks are written with keys hidden in the laws of physics. As you imagine this process, think of how it mirrors the rhythm of our own existence: the slow, unnoticed passing of moments, the steady leaking of time. Like a black hole, we too are luminous in ways we cannot always perceive, unraveling gently into the infinite night. When galaxies meet, the event seems as if it should be apocalyptic, billions of stars rushing together, crashing, and tearing apart. Yet, in truth, the collisions unfold in silence. The reason is both simple and profound. The vast distances between stars mean that even when galaxies pass through one another, individual stars almost never collide. Instead, they weave around each other, shifting under the pull of gravity like dancers crossing paths on a floor too wide to touch. What we imagine as chaos is, in fact, a slow, ghostly ballet in the void. You can picture our own Milky Way drifting toward its neighbor, the Andromeda Galaxy. In roughly 4 billion years, their shapes will begin to merge. From a human perspective, it is a timescale impossible to feel, a span in which continents will move, mountains will rise and vanish, and civilizations will come and go many times over. Yet on that scale, the galaxies themselves act almost like living beings. Their spiral arms stretch, distort, and tangle, while streams of stars are drawn out like ribbons unraveling into space. Despite the immensity of the event, if you could somehow watch it from a safe vantage point, it would feel strangely calm. There is no sound in space, no roar or thunder, only the silent exchange of gravitational energy. Entire solar systems might be nudged into new orbits, some flung outward, others pulled inward toward the combined core. For planets circling their stars, life would continue without any sense that their cosmic neighborhood had shifted. A night sky might change over millions of years, familiar constellations dissolving into unfamiliar patterns, but the transition would be so gradual it would escape notice in a single lifetime. In this quiet merging lies a paradox: violence without noise, destruction without immediate chaos. The result of such collisions is not an ending but a rebirth, as two galaxies become one. Stars will still form in the turbulence, lighting the dark with newborn suns. And in that silence, the universe continues its endless rhythm, where even collisions are a form of creation. Imagine standing on a quiet shore, watching waves roll in, unaware that the very air you breathe, the oceans before you, and the soil beneath your feet all depend on a hidden guardian. Earth is wrapped in an invisible shield, a magnetic bubble, generated deep within the planet's molten core. This shield, known as the magnetosphere, bends and deflects streams of charged particles hurled toward us by the sun. Without it, every solar storm would strike directly, burning away atmosphere and sterilizing the ground. It is not a visible wall but a subtle force, like unseen hands always at work, holding back chaos. Daily life unfolds as though this shield were eternal. Farmers once sowed their fields without ever knowing that their crops were safe because magnetic lines overhead diverted solar winds. Sailors steered ships guided by compasses that quietly aligned with Earth's magnetic field, never questioning the source of such order. Even now, planes trace their courses across polar skies while the aurora dances above, a visible reminder of this constant cosmic struggle. The shimmering lights, beautiful and serene, are actually the side effects of Earth's shield taking the blow. But this defense is not unshakable. Throughout history, the magnetic poles have shifted, weakened, and even flipped entirely. During such times, records suggest that the barrier thins, leaving Earth more vulnerable. Scientists study traces locked in rocks and sediments, hints of ancient reversals where the shield faltered. Imagine oceans slowly stripped, atmospheres thinned, life forced into fragile corners. Mars stands as a warning. Once flowing with rivers, it lost its own shield, and the winds of the sun claimed the rest. For now, Earth's magnetic cocoon holds steady, though it murmurs with change. The shield that protects you is silent, unseen, yet ceaselessly at work, a quiet guardian against the sun's relentless fire. And somewhere deep inside the planet, molten iron stirs, generating the pulse that keeps this fragile balance alive. Would you like me to prepare this in a series of connected segments, like daily life, mystery, social contrast, etc., so it can flow more seamlessly into your 3-hour structure rather than just a single standalone script? Imagine walking beneath a night sky so vast it feels endless. You see stars scattered like grains of salt across black velvet, galaxies faintly spiraling in the distance. Yet what you cannot see is far greater than what shines. Hidden in the darkness is a web of matter that does not glow, does not reflect, and cannot be touched. Scientists call it dark matter, an unseen framework that shapes the universe itself. Without it, galaxies would unravel, stars would drift apart, and the sky you know would not exist. Think of it as an invisible skeleton, a silent structure binding everything together. The stars we admire are like beads on threads we cannot see, arranged along filaments of this cosmic web. When astronomers map the universe, they find vast clusters of galaxies drawn into patterns too large and delicate to be random. These shapes hint at something holding them in place, something that outweighs all visible matter by 5 to 1. Imagine yourself standing in a quiet forest. You notice the leaves, the bark, the shifting light, but beneath it all, there are roots, deep and unseen, anchoring everything. Dark matter is like those roots, necessary, hidden, and silent. And yet, no one has touched a particle of it. We infer its presence through its pull, through the way galaxies spin too fast to be explained by ordinary matter alone. Astronomers measure these motions, trace the missing mass, and point toward the invisible. But still, it remains unproven, a theory suspended in evidence yet beyond reach. In daily life, you never feel this hidden weight pressing on your shoulders, yet every star you see is bound by it, every world is held in place because of it. There is comfort in imagining that most of what exists cannot be seen, that mystery is not an absence but a presence. As you drift into thought, remember, the universe is not only what is visible, but also the vast silence of what is unseen, binding everything in a web of stillness. Imagine yourself holding a simple clock, its steady tick marking the rhythm of ordinary life. Each second feels absolute, the same no matter where you are. Yet physics tells a stranger story. Time itself bends and stretches, depending on where you stand in the universe. Near stronger gravity, clocks slow down. On the surface of Earth, time moves just a little differently than it does above the clouds. For someone living high in the mountains, their seconds pass ever so slightly faster than those at sea level. The difference is so small that no one notices, but it is there, written into the flow of reality itself. Now imagine astronauts in orbit. Far above Earth's pull, their clocks run faster than those on the ground. At the same time, because they are moving so quickly, relativity slows them down again. The balance between motion and gravity creates a subtle paradox. Two people can leave the same moment, live through their days, and return having measured time differently. It has been proven with atomic clocks carried on airplanes and satellites, their delicate hands drifting apart from those that stayed behind. Think of the quiet routine of daily life. Farmers rising with the dawn, workers pausing at midday, children counting minutes until the school bell rings. All of them trust time as steady, as universal. Yet above them, aboard the International Space Station, astronauts move through days and nights not quite aligned with ours. They orbit Earth every 90 minutes, watching sunrises and sunsets flicker past in rapid succession, their bodies aging just a trace differently than yours. And so you find yourself in a world where every step, every heartbeat, is touched by this subtle bending of time. Imagine the comfort of knowing that no clock is perfectly absolute, that even the most precise measures drift with the shape of space itself. You live not by rigid seconds, but within a universe where time itself is alive, shifting gently around you. Imagine yourself beneath a night sky, watching the faint shimmer of distant stars. To the eye, they appear silent, fixed points of light against endless darkness. Yet, hidden beneath that calm glow, stars are not quiet at all. They vibrate, ripple, and resonate, producing frequencies that move through their vast interiors like notes in a giant instrument. These oscillations, called stellar seismology, can be detected by sensitive instruments, translating their subtle pulses into sound. What emerges is not a song we could hear with our ears, but patterns of rhythm and tone, an ancient music that speaks of density, heat, and the hidden structure of a star's heart. Astronomers describe these vibrations much like the strings of a cello or the air column of a flute, each star shaped by its own size and age, producing unique signatures. A massive star may hum in deep, slow frequencies, while smaller stars ripple with lighter, quicker tones. Listening to them through converted data feels like entering a concert hall where the performers are suns scattered across the galaxy, each one contributing its own timbre to a cosmic symphony. These stellar songs are not composed for us, yet they tell us stories. By studying the vibrations, scientists can peer inside stars in ways no telescope could allow, unraveling details of their inner layers and life cycles. What once seemed like silent, distant fire now becomes intimate, almost familiar, as though the universe itself is breathing in sound. And as you drift in thought, consider the comfort of this hidden harmony. Even in the emptiness of space, there is rhythm, there is resonance, there is music written into the fabric of the stars. The sun has always seemed eternal, a steady presence above us, rising and setting with unbroken rhythm. Yet like all stars, it carries within it a quiet destiny. Today it shines in balance, its immense gravity pulling inward while nuclear fusion pushes outward, a perfect equilibrium that allows warmth, light, and life to exist here on Earth. But in time, measured not in centuries, but in billions of years, this balance will break. As the sun exhausts its supply of hydrogen fuel, its core will contract and heat, while its outer layers swell outward. Imagine the blue sky one day washed in a larger, redder glow, as the sun expands into what astronomers call a red giant. Mercury and Venus will be the first to vanish, consumed within its fiery reach. Earth, too, may not escape. The oceans would boil away long before the surface was swallowed, and the familiar patterns of mountains, rivers, and cities would fade into silence beneath a deepening heat. Yet this process is not abrupt. It is gradual, unfolding over immense stretches of time, so slow that no single human generation would sense the change. For creatures living then, if any remained, the night sky would still hold stars, but the days would carry a sun heavier, softer in color, more diffuse across the horizon. When the outer layers are finally cast off, the sun will leave behind a dense white core, a white dwarf, glowing with fading memory. Around it, a cloud of gas and dust will shimmer, a planetary nebula carrying traces of everything that once burned in its heart. It is not destruction so much as transformation, the materials of one star becoming the raw ingredients for what may, far in the future, shape new worlds. Even the end of the sun's life is part of the quiet rhythm of the cosmos, where endings are never absolute, and silence often hides the promise of beginnings. Imagine yourself drifting far beyond Earth, away from the air, the clouds, the warmth of sunlight on stone. Out here, in the vast openness we call space, there is no wind, no sound, and no air to carry heat. People often describe space as unimaginably cold, but the truth is subtler. The vacuum itself has no temperature at all. Temperature is the measure of how fast particles move, and in empty space there are almost none to measure. Instead of a chill, there is simply absence, a silence so complete that even warmth has nowhere to settle. If you were to hold a hand out into that void, nothing would brush against your skin. No particles to cool you, no air to steal your heat. Objects in space lose or gain warmth only through radiation, slowly glowing away energy or absorbing sunlight. A rock in shadow can fall to freezing darkness, while a panel lit by the sun may bake hotter than desert sand. It is not cold or hot in the way we experience weather, but rather an endless contrast shaped by the presence or absence of light. Astronauts who floated outside the safety of their ships described the stillness as eerie. Through the visor, they saw Earth hanging blue and alive, while behind them stretched blackness deeper than any night sky. Their suits worked quietly to regulate temperature, not from the vacuum stealing it, but from the extremes of radiation pressing in from every angle. Imagine the delicate balance of systems keeping them steady, caught between searing sun and infinite shadow. From a distance, space feels like nothing at all, and yet that very nothingness shapes every star, every planet, every breath we take. The vacuum does not freeze, it simply waits, patient and indifferent, holding the stage on which the drama of matter and energy unfolds. Imagine setting out on a journey through the universe, moving past stars, past galaxies, past the quiet emptiness between clusters of light. You might expect, after enough distance, to come upon a boundary, some kind of wall or horizon where everything ends. But the cosmos offers no such edge. Instead, it curves gently back into itself, like the surface of a sphere so vast you cannot see its shape. No matter how far you travel, you would never arrive at an ending point. You would only loop back into the fabric of the universe again, carried in circles across an expanse without borders. This idea can feel strange, because daily life is filled with edges and boundaries. Roads end. Oceans meet land. Even the horizon, which appears endless, eventually curves into the planet beneath your feet. But the universe resists that pattern. Space itself bends in ways our senses cannot grasp. Imagine walking across the Earth. If you keep moving in one direction, you never fall off, you simply return to where you began. The universe may work in a similar way, though on a scale so immense it cannot be measured by human travel, only by patient observation of light itself. Astronomers study this through the faint glow of ancient radiation and the clustering of galaxies, searching for signs of curvature. The evidence suggests that the universe may be flat, stretching endlessly, or gently curved, folding back on itself in dimensions our minds struggle to imagine. Either way, there is no sharp boundary, no cosmic cliff where existence stops. Instead, there is continuity, an unbroken flow of space and time, weaving on without interruption. There is something quietly comforting in this. To live in a universe without edges is to live in a story without an ending line, a place where motion continues, and where boundaries are illusions of our limited sight. When you look into the night sky, you are not staring toward an edge. You are gazing into a curve that holds you, endless and whole. Imagine yourself gazing at Saturn, its pale golden bands wrapped around by delicate rings that shimmer like frozen music. At first glance, it seems impossibly massive, a giant that dwarfs Earth many times over. Yet here lies the quiet paradox. If you could place Saturn into a vast cosmic ocean, it would float. Despite its size, Saturn's density is less than that of water. The gases that form its body, mostly hydrogen and helium, are so light that this world of storms and swirling clouds would drift like a hollow vessel upon a sea. Consider daily life near rivers or coasts, where boats and rafts have always relied on the principle of buoyancy. Ancient fishers trusted wood because it floated, farmers carried goods across water on vessels carved from trees. None could have imagined that an entire planet, thousands of times heavier than their world, followed the same principle. The laws that allowed a wooden canoe to stay afloat on a quiet lake are the same that would let Saturn rest upon an imaginary galactic ocean. Astronomers measure such things not in myth but in numbers. They know Saturn's average density is about 0.7 grams per cubic centimeter, lighter than water's 1 gram. That single comparison reveals the strangeness of nature. Mass does not always mean weight, and size does not always mean heaviness. For all its grandeur, Saturn is a fragile giant, its body so diffuse that it would not sink but rise. Imagine yourself standing beneath the night sky, looking up at the faint glimmer where Saturn shines. It is distant, but the thought of a world large enough to hold dozens of Earths, yet delicate enough to float, invites reflection. The rhythm of its storms, the endless spin of its rings, continue in silence, bound by gravity but lighter than the seas you know. In this way, Saturn becomes both immense and strangely fragile, a giant that, in another setting, could drift like a leaf across water. Imagine standing at the edge of a quiet shore, watching the tide breathe in and out, unaware that this rhythm is slowly changing. The moon, Earth's constant companion, has never been entirely still. With each passing year, it drifts a little farther away, about 4 centimeters annually. It is such a small distance that you would never notice it in your lifetime, and yet, over millions of years, it reshapes the bond between planet and satellite. The moon once hovered much closer, looming larger in the sky, pulling tides with a force that shaped early coastlines and guided the rhythms of primitive life. Now, it retreats at a steady pace, as though slipping gently from Earth's embrace. This drifting is caused by a quiet exchange of energy. Earth's rotation stirs the oceans, tides push against the seafloor, and in turn, the moon is nudged outward. What feels like a still partnership is, in reality, a slow unwinding. As the moon drifts away, Earth's rotation also changes. Days lengthen, little by little, as though time itself is being stretched. 1 billion years ago, a single day may have lasted only 18 hours. In the far future, days will grow even longer, while tides become softer, their pull weaker and more subdued. To imagine this is to think of a dance slowly loosening, partners stepping apart, the music continuing but at a gentler tempo. The Earth and Moon remain bound, but their relationship is never static. It is a reminder that even what seems constant, our tides, our days, the glowing presence in the night sky, is quietly shifting. The moon is not leaving us suddenly, nor will it vanish from our lives any time soon. Instead, it is the slow poetry of cosmic drift, written in inches each year, altering the rhythm of our planet in silence. A star's life may last millions or even billions of years, yet its end can arrive in a single instant of staggering release. When a massive star exhausts the fuel in its core, the delicate balance between gravity pulling inward and fusion pushing outward collapses. For ages, the star has quietly forged heavier and heavier elements, hydrogen into helium, helium into carbon, and beyond. But eventually, it reaches iron, a weight it cannot transform further. Gravity wins, and the core implodes. What follows is a supernova. In just seconds, the star emits more energy than our sun will generate in its entire 10 billion-year life. Imagine yourself beneath that sky. A star that had always seemed distant and eternal suddenly outshines its galaxy, visible even in daylight. The explosion tears apart the star's layers, casting them into space at immense speed. It is violent, yes, but in the vacuum of the cosmos, it unfolds without sound, an eruption seen, but never heard. From Earth, ancient observers sometimes recorded such events, calling them guest stars. In 1054, Chinese astronomers noted a brilliant light that lingered in the sky for weeks, visible even by day. What they saw was a supernova that left behind the Crab Nebula, still visible through telescopes today, its filaments spreading outward like threads of memory. And yet, this destruction is also creation. The very iron in your blood, the calcium in your bones, and the oxygen you breathe were once released in such cosmic deaths. A supernova is both an ending and a gift, scattering the raw materials from which planets, oceans, and life itself can emerge. Even the most violent end becomes part of a larger cycle. In silence, the universe recycles its stars, ensuring that from each death, countless futures can quietly take shape. Imagine yourself lying beneath a dark sky, watching points of light scattered across the void. Each star feels fixed, steady, a quiet reassurance that the universe is unchanging. Yet when astronomers began to measure galaxies carefully, they discovered something unsettling. The farther away a galaxy is, the faster it races from us, its light stretched into a deepening red. This expansion is not a drift through space, but space itself stretching, carrying entire galaxies farther apart with every passing moment. It is as if the fabric beneath all things is being pulled gently outward, endlessly. For daily life, the pace of this growth is invisible. You still wake to the same sunrise, trace the same constellations, measure the same distances on Earth. But far beyond, distances double and redouble, a rhythm too vast for human senses. Ancient light takes billions of years to reach us, only to whisper that its source has already moved far beyond where we see it. Imagine looking at a lantern across a field, and by the time its glow reaches you, the lantern has already been carried into another valley. The mystery deepens because this expansion is not slowing, it is speeding up. Scientists describe an unseen force, dark energy, driving galaxies apart faster than light can chase. It is not that matter moves beyond light's speed, but that the stage itself, space-time, stretches faster than light can cross it. The result is a horizon, regions of the cosmos receding so quickly that their signals will never reach us. Entire galaxies slip quietly beyond visibility, as though vanishing into silence. The universe, then, is not a stable backdrop but a living motion. It swells with a quiet persistence, each moment more distant than the last. And here you are, a small observer on a single world, watching an expansion so vast it may never end, wondering if space itself is writing its own escape beyond your sight. Imagine the universe as a grand stage, yet most of that stage is bare. Between galaxies lie immense distances where no light shines, no warmth flickers, only silence. Even within a single galaxy, stars that look close together from Earth are in fact separated by trillions of miles. And when you go deeper still, inside an atom, you find the same story repeated. Electrons orbit a tiny nucleus with so much empty space between them that if the nucleus were the size of a grain of sand, the nearest electron might be a football field away. The structure of reality, at every level, is built on vast gaps of nothingness. Daily life does not reveal this emptiness. The chair you sit on feels solid, your hand appears whole, the air seems full. Yet what feels solid is mostly void, with particles so small and so widely spaced that their emptiness is disguised by the strength of their bonds. Imagine yourself standing in a wide desert where dunes are scattered far apart. From a distance it looks like a landscape of form, but as you walk, you realize it is mostly open air. Matter is like that, scattered islands in oceans of absence. Astronomers describe the universe as a kind of web. Galaxies gather along invisible filaments, separated by expanses where almost nothing exists. To travel across those dark gulfs would take millions of years, even at the speed of light. And yet, this emptiness is not wasted. It gives structure to what is. Without the space between, stars could not shine freely, atoms could not form, and we could not breathe in the illusion of solidity. There is a quiet paradox in this truth. Everything you know, everything you are, depends on emptiness as much as matter. The universe is not crowded but sparse, and in that sparseness it finds its balance. As you drift into thought, remember, the silence between stars, the gap between particles, is not absence, but the very space that allows existence to unfold. Imagine yourself drifting in silence far beyond the warmth of our sun, into a region where even starlight feels thin and fragile. There lies the Boomerang Nebula, a faint, ghostly cloud some 5,000 light-years away. It holds a strange record, the coldest natural place ever found. Within its expanding gas, temperatures sink to just 1 degree above absolute zero, the point where motion itself almost ceases. No laboratory on Earth, no carefully built machine, has matched such vast and effortless chill. Think of daily life where cold shapes survival. People bundle in heavy furs, fires flicker in hearths, frost clings to windows. Even in Earth's harshest winters, where Arctic winds howl across empty ice, the air still holds more warmth than the Boomerang Nebula. The farmers who once measured seasons by the coming of frost, the explorers who endured nights at -50, all lived in temperatures that would feel blazing compared to the stillness of this cosmic winter. Astronomers explain it through physics. A dying star at the center of the nebula is shedding its gas so quickly that the material expands and cools more efficiently than anything we can recreate. As the gas spreads outward, it loses nearly all its heat, leaving behind a cloud so frigid that molecules barely move. The name boomerang comes from its shape, but it might as well describe how heat itself flees and never returns. Imagine yourself looking at the night sky, its countless stars appearing eternal. Hidden among them, the Boomerang Nebula glows faintly, holding a silence beyond anything you can feel on Earth. It is a reminder that cold is not just absence but presence, a vast, quiet force shaping the universe. While we build fires, light lamps, and warm our homes, out there exists a place where even warmth has surrendered, leaving only the faint echo of a dying star wrapped in unimaginable frost. Imagine yourself looking at the night sky, its canvas scattered with points of light that stretch far beyond counting. Astronomers estimate that within our galaxy alone, the Milky Way, there may be more than 100 billion planets. Among this staggering number, Earth is but one, an almost invisible speck circling an ordinary star in a modest spiral arm. From here, the planet feels immense, with oceans that seem endless and mountains that rise beyond sight. Yet when placed against the scale of the cosmos, it is fragile, temporary, almost delicate, like a grain of sand resting on the shore of an infinite sea. This perspective does not diminish Earth's importance. Instead, it reshapes how we see it. Imagine the galaxy as a great city of stars, each with its own neighborhoods of orbiting worlds. Most of these planets remain hidden, unknown to us except through faint traces of their shadows across starlight. Some may be barren rocks, others gas giants with storms larger than Earth itself. A few might carry seas or skies, conditions that mirror or challenge our own. In this vast diversity, Earth stands out only to us because it is the stage of our memories, our histories, our fragile lives. To think of our planet this way is to feel both small and profoundly connected. We are not at the center of the story but part of a much larger pattern, woven into the fabric of a galaxy still unfolding. The dust of Earth is the dust of stars, recycled across ages, gathered for a brief moment into the form of oceans, forests, and breath. And as you let your thoughts drift, you may sense a quiet comfort, that our tiny place is not a flaw but a reminder of how extraordinary it is to exist at all in the middle of such endlessness. High above you, far beyond the blue of the sky, the universe is never still. Stars explode, galaxies collide, and in their wake streams of invisible travelers race outward. These are cosmic rays, charged particles hurled across interstellar distances, carrying immense energy. By the time they reach Earth, they have already traveled for millions of years, passing through magnetic fields and clouds of gas until, finally, they arrive here. Every second, some of these particles pass through your body. You cannot see them, cannot feel them, and yet they are there, tiny fragments of distant stars quietly brushing through skin, bone, and even DNA. The vast majority do no harm. They move on, unnoticed, leaving no trace. But occasionally, they strike at just the right angle, disrupting a molecule, altering a sequence, writing an invisible story inside your cells. In this way, the distant universe leaves faint signatures written into the biology of life on Earth. Ancient civilizations once imagined that the heavens influenced our fate, crafting myths of divine arrows or heavenly fire. Today, we know that in a small, literal sense, this is true. Cosmic rays constantly thread through us, their origins tied to events unimaginably distant. Some may come from the sun, released during solar flares, while others are born from violent supernovae or even more mysterious sources beyond our galaxy. Yet for all their power, they are also reminders of connection. You breathe here, grounded on Earth, while fragments of stars billions of light-years away pass silently through you. The boundary between self and cosmos is thinner than it seems. In this quiet exchange, You are part of a story written across the universe, one invisible particle at a time. Imagine yourself standing at the boundary of the known, gazing into a place where the rules of the universe bend beyond recognition. This is the event horizon of a black hole, the invisible edge where escape becomes impossible. Here, even light, swiftest of all travelers, cannot break free. To cross this threshold is to step into a one-way passage, not into space as we know it, but into a domain where time itself is pulled and stretched until it unravels. Daily life offers no true comparison. You may think of a river current so strong that no swimmer can resist, or a horizon you can see but never reach. Yet the pull of a black hole is not felt as a sudden force. It is gravity woven so deeply into the fabric of spacetime that every path forward bends inward. Imagine yourself drifting closer, watching clocks outside tick faster while your own time slows, stretched by gravity's relentless hold. To an outside observer, you would appear frozen at the edge, never quite crossing. Yet from your view, the fall is unstoppable. Scientists once debated whether such places could even exist. It was only in the 20th century, with the work of Schwarzschild and later Hawking, that the event horizon became more than a mathematical curiosity. Now we know it is real, captured even in the faint glow of an image, a ring of fire surrounding a shadow that nothing can escape. Beyond it lies mystery, whether matter is destroyed or whether information lingers, encoded in ways we cannot yet understand. The event horizon is not a wall but a boundary of knowledge, a reminder that there are places where certainty dissolves. It is the line where the universe whispers, "You may look, but you cannot return." Imagine looking up at the night sky and seeing countless points of light. To your eyes they seem solitary, each one a lonely beacon against the dark. Yet the truth is almost the opposite. Most of those stars are not alone at all. They come in pairs, or sometimes in trios, bound together by gravity in a silent, endless orbit. These are binary stars, two suns circling a shared center of mass, locked in a dance so steady it may last for billions of years. Our own sun, with its solitary path, is unusual, a quiet wanderer in a universe where companionship is the rule. Think of daily life, neighbors sharing walls, families gathered around a table, the rhythm of life defined by connection. Stars, too, share their lives. In some systems, the two suns are close, appearing to touch, trading streams of gas that glow with heat and light. In others, they orbit far apart, so distant they seem isolated until you follow their paths and realize they are bound by invisible threads. Imagine yourself standing on a planet in such a system, watching two suns rise, one after the other, painting the sky with shifting patterns of color and shadow. Astronomers have long studied these pairs, for their motions reveal secrets of mass and distance. By watching how one star tugs on another, scientists measure the unseen, calculating the weight of worlds light years away. Binary stars have even given us clues about black holes and exotic objects, because when one companion collapses, the other bears silent witness in its orbit. There is something comforting in this pattern, that even in the vast loneliness of space, most stars are not truly alone. They turn together, age together, and sometimes die together, leaving behind echoes of their shared journey. When you look into the night sky, remember, many of those distant lights are not single voices, but duets, weaving their harmony across the silence of the cosmos. Imagine yourself trying to picture a moment before everything. A silence before silence, a darkness before dark. The mind naturally searches for a beginning, for something to stand before the first step. Yet physics tells us that time itself began suddenly, at the Big Bang. There was no ticking clock, no waiting emptiness, not even the word before. The universe expanded from a single point of energy and space, and only then did seconds, minutes, and ages unfold. To ask what came earlier is to use language that no longer applies, like asking what lies north of the North Pole. Think of daily life, where time is constant, unquestioned. Farmers mark the seasons by the tilt of the sun. Children wait for days to pass before birthdays arrive. Even the smallest tasks, lighting a lamp, cooking a meal, depend on time's steady rhythm. Yet the very existence of that rhythm had to be born. There was once no flow at all, until the first expansion gave rise to duration, change, and history itself. Astronomers and philosophers alike wrestle with this paradox. Ancient myths spoke of gods emerging from chaos, of worlds born from eggs or oceans without shores. In their way, they were reaching for the same mystery. How can something emerge from nothing, and how can nothing be spoken of at all? Modern physics reframes the question, suggesting that the universe may have arisen not out of emptiness, but out of a state where our concepts of time and cause simply break down. Imagine yourself under a night sky, each star burning with light that has traveled for billions of years. Those years are only possible because time began. The ticking of your clock, the rhythm of your breath, the unfolding of your own memories, all are echoes of that first instant. The universe did not wait in silence. It began with a sudden unfolding, carrying you within it every moment since. Imagine holding an ordinary teaspoon, the kind you might stir into a quiet cup of tea. Now imagine filling it not with sugar or salt, but with the matter of a neutron star. That single spoonful would weigh billions of tons, so heavy it could crush mountains, so dense it defies ordinary comparison. Neutron stars are what remain when massive stars collapse, their cores squeezed by gravity into an object no wider than a city but heavier than the sun. Atoms themselves are broken down, electrons and protons pressed together until nothing is left but neutrons, packed side by side in unimaginable density. To grasp this, picture the familiar spaces between you and the things around you. In our world, matter is mostly empty. Atoms are tiny nuclei surrounded by vast clouds of space. In a neutron star, that space is gone. Matter is compressed into its raw essence, as if the universe itself demanded no waste, no gaps, only compact weight. The surface is thought to be hard and unyielding, while the interior may resemble a strange ocean of neutrons flowing under crushing pressure. Despite their size, neutron stars hold enormous influence. Some spin dozens of times a second, sweeping beams of radiation across space like cosmic lighthouses. Others exist in pairs, spiraling inward until they collide, releasing bursts of energy that ripple through spacetime as gravitational waves. These distant events remind us of the raw power hidden in the smallest of volumes. As you let your thoughts settle on this image, consider the paradox, that the tiniest spoonful could outweigh entire mountains, that what looks like emptiness in our everyday world is actually potential waiting to collapse. It is a quiet lesson in extremes, that density, not size, can hold the most profound weight. When you look at the night sky, it seems full, thousands of stars scattered across a black canvas, galaxies hidden just beyond sight. It feels complete, as if what you see is all there is. Yet, strangely, everything we can observe, planets, stars, clouds of gas, even dark matter, makes up only a fraction of the universe. Nearly 70% is something else, something we cannot see or touch, something scientists call dark energy. Dark energy reveals itself not by what it is, but by what it does. In the late 1990s, astronomers measuring distant supernovae noticed a strange pattern. Instead of slowing down, the universe's expansion was speeding up. Galaxies were not just drifting apart, they were being pushed away faster and faster. The simplest explanation was an unseen force, woven into the very fabric of space itself, acting as a kind of cosmic pressure that stretches the universe wider with every passing moment. Imagine yourself standing in an open field, watching the horizon grow farther away in all directions. No matter where you turn, the distance increases, not because you move, but because the ground beneath you is quietly expanding. That is the effect of dark energy on the cosmos. Galaxies are carried farther from one another, and as time continues, the universe grows colder, emptier, and more diffuse. What exactly dark energy is remains one of science's greatest mysteries. It could be a property of space itself, a kind of vacuum energy that resists compression. Or it might be a field that changes with time, something dynamic and still unfolding. We do not yet know. All we know is its influence, measured in the accelerating motion of galaxies light-years away. In this way, the universe reminds us of its quiet strangeness. Most of what exists cannot be seen directly, and yet it shapes everything we know. You are living in a cosmos where the dominant force is invisible, its nature uncertain, its reach beyond measure. Imagine yourself looking at a map of the world, tracing the outlines of continents, the familiar shapes of Africa, Asia, and the Americas. It feels permanent, as though the land has always been arranged this way. Yet the ground beneath your feet is not fixed. It drifts slowly, pulled by currents deep within Earth's mantle. Over millions of years, continents wander, collide, and tear apart. The face of the planet you know today is only one chapter in a much longer story. In daily life, the movement is too slow to notice. A mountain rises by mere millimeters each year, while an ocean floor spreads grain by grain. But across the span of geological time, these subtle motions reshape everything. Once, all land was joined as a single supercontinent, Pangaea, and before that, others had formed and broken apart. In the far future, they will drift together once more, closing oceans and lifting new mountain ranges where seas once lay. Imagine deserts turned into coastlines, islands swallowed into new interiors, entire climates remade. Scientists project that in 200 to 300 million years, the continents may gather again into a vast supercontinent. It might circle the equator like a giant belt or cluster around the poles, plunging global climates into extremes. Life will adapt, just as it has through every upheaval. Species will vanish, others will rise, carving new paths through landscapes that no one alive today would recognize. The earth you walk upon is not static but restless, always writing and rewriting its surface. To you, the mountains seem eternal, the oceans endless, the valleys timeless. Yet given enough years, all will shift, fold, or vanish. The world of tomorrow will be alien not because it lies among the stars, but because the ground itself will have wandered into forms no map has ever drawn. Imagine a newborn planet, its surface still raw and unstable, covered in molten plains and restless seas of vapor. Into this young world comes a visitor from the cold edges of the solar system, a comet, small in size but rich in meaning. These icy travelers carry with them frozen water and organic molecules, fragments of chemistry formed long before planets themselves. When they strike, they deliver not just ice, but the ingredients of possibility, the seeds from which life might one day emerge. Daily life offers echoes of this idea. Think of rain nourishing dry soil, or seeds scattered by the wind, settling into places where they might take root. Comets perform a similar role on a cosmic scale. They wander for millions of years through the silent dark, then, drawn inward by gravity, they sweep past suns, shedding luminous tails that stretch across the sky. To ancient eyes, those glowing arcs were omens. To modern science, they are archives of the early solar system, holding materials untouched since creation's beginning. Some theories suggest Earth's oceans themselves may be gifts from comets, their frozen cores releasing water that pooled into seas. Along with water came carbon-based molecules, the building blocks of proteins, DNA, and the fragile patterns that sustain life. Imagine yourself tracing your own breath back through time, realizing it may carry atoms once locked in a comet's ice, delivered billions of years ago. And still, comets travel. Across galaxies, across epochs, they move as quiet couriers, carrying potential wherever they fall. There is comfort in this rhythm. Life may not be confined to one world, but seeded again and again, in places yet unborn. To watch a comet is to glimpse both history and possibility, a reminder that even the smallest travelers can change the fate of entire worlds. Imagine yourself looking up at the night sky, where each star appears calm, steady, and eternal. Yet behind that distant glow, many stars live double lives. Some are not content to shine quietly on their own. They orbit close to companions, bound together in binary systems. Over time, one star begins to draw matter from the other, pulling gas across space as if feeding from its partner's very body. Astronomers call this stellar cannibalism, and though the word feels fierce, the process unfolds silently, invisibly to the eye, across thousands of years. Think of daily life where sharing and taking intertwine. Fields divided among neighbors, markets where goods are exchanged, even households where food passes from hand to hand. But in the heavens, there is no balance. A stronger star siphons its companion, stripping it layer by layer until the victim weakens or collapses entirely. The stolen matter spirals in, forming brilliant disks of hot gas. To astronomers, these disks glow with X-rays and sudden bursts of light, signals of a quiet violence we cannot see from Earth's surface. The fate of such unions is rarely peaceful. Sometimes the two stars merge, forming a single, larger giant that burns with renewed energy. At other times, the imbalance triggers explosions, novae or even supernovae, that scatter matter back into space. The paradox is striking. From destruction comes creation, as these violent endings seed galaxies with heavy elements that later form planets, oceans, and even life. Imagine yourself standing in a quiet field at night. The stars above seem distant and still, yet hidden among them are these stories of hunger and collapse. A calm light may, in truth, be the aftermath of struggle, a survivor of a union that ended in fire. And so the sky you see is not only serene but layered with memory. Reminders that even in the vastness of space, existence is shaped by bonds, by taking and giving, by lives lived twice. Imagine standing in a vast field at night, horizons stretching in all directions, and knowing that no matter how far you walk, there will always be more beyond your sight. The universe offers a similar limit, not because it ends, but because light itself has only had so long to travel. From our small planet, we see a sphere, a bubble, about 46 billion light-years wide. This is the observable universe, the portion from which light has reached us since the beginning of time. Beyond that horizon, galaxies continue, space expands, reality stretches on without boundary. But to us, it is forever hidden, a landscape we can never enter, a silence we can never break. What we see is already ancient. The most distant galaxies glow as they were billions of years ago, their light stretched and dimmed by expansion. Even as we observe them, they drift farther away, carried beyond the speed of light by the stretching fabric of space. In this way, the cosmos keeps secrets. There are stars and planets, entire clusters of galaxies, that exist but will never appear in our skies. They lie outside the bubble of our knowing, beyond the frontier of what light can deliver. To imagine this is to feel both humbled and comforted. The horizon is not a wall but a mirror of our own limits, an edge defined not by the universe but by the speed of time itself. As we drift through space, the bubble continues to expand, yet always there will be more unseen than seen. Like standing at the shore of an ocean without end, we glimpse only the waves near us, never the full depth of water stretching beyond the horizon. And so the observable universe is both vast and small, a 46 billion light-year window in a cosmos that may be infinite. It reminds us that our vision, though powerful, is always partial, and that the greatest mysteries are not in what we see, but in what we will never reach. Black holes are often imagined as silent voids, simple wells in space that swallow all that comes near. Yet they are more dynamic than this picture suggests. Some of them spin, rotating with such ferocity that their edges move at nearly the speed of light. This spin is not merely motion. It drags space itself into rotation, a phenomenon known as frame dragging. Around these black holes, time and distance twist, as if reality were being stirred like liquid glass. The spin begins with the star that collapsed to form the black hole. Just as a figure skater spins faster by drawing in their arms, the collapsing core spins faster as it shrinks. Over cosmic time, a black hole can also gain momentum by feeding, drawing in gas, stars, and even smaller black holes, each adding their motion to its own. The result is a whirlpool of gravity so intense that nothing, not even light, can resist its pull once it crosses the event horizon. Imagine yourself drifting near such a spinning giant. To an outside observer, the space around you would no longer be fixed. Instead, it would swirl, carrying you in circles even if you tried to remain still. If you dropped a beam of light into this distorted region, it would not travel straight, but curve and twist, dragged along with the rotation. Scientists studying these objects detect their spin indirectly, by observing the disks of matter spiraling inward. The radiation from this matter grows hotter and brighter the faster the spin. In some cases, energy can even be drawn out, powering immense jets that shoot for thousands of light-years, carrying material far beyond the galaxy's heart. And yet, despite this violence, there is silence. You cannot hear space itself twist, nor feel time accelerate beneath your feet. The black hole spins on, unseen, like a hidden engine, its motion recorded only in the way it bends the universe around it. Imagine yourself gazing up at the moon on a clear night, its pale face quiet and barren. It feels timeless, a place untouched by change. Yet billions of years ago, the moon was not the silent world we know. After massive volcanic eruptions spilled rivers of molten rock across its surface, gases like carbon monoxide, sulfur, and water vapor seeped upward, creating a fragile atmosphere. For a time, the moon carried a veil of air, thin, fleeting, but real. Daily life on Earth continued unaware, oceans forming and life's first steps beginning, while overhead, the moon glowed with a faint halo of gases. This atmosphere was never as thick as Earth's, but it was enough that, if you could have stood there, the horizon might have seemed softened by haze instead of sharp blackness. Imagine a faint shimmer around craters, a ghostly envelope sheltering the surface. But the moon's gravity was too weak to hold it. Without a magnetic field to shield against the solar wind, streams of charged particles from the sun slowly stripped the atmosphere away. In only tens of millions of years, brief in cosmic terms, the gases vanished into space. What remained was a silent surface, airless and exposed, with only traces locked into the rocks as evidence of what once was. Scientists pieced together this story through lunar samples and models of ancient volcanic activity, revealing a past almost forgotten. The moon you see today, cold and breathless, once exhaled and held a fleeting breath of its own. It reminds us that worlds can change profoundly, not only over eons, but in ways invisible to those who come after. The silence above hides a history of loss, written into dust and stone. Imagine a galaxy, its spiral arms stretched wide, stars scattered like dust across a canvas of dark. At its heart lies something you cannot see, something that gives no light of its own, a supermassive black hole. Nearly every galaxy we know carries one, hidden at its center, as though creation itself requires a dark anchor. These giants are millions, sometimes billions, of times the mass of our sun. They feed quietly, drawing in gas, dust, even stars that wander too close, folding them into silence. Daily life rarely prepares us for such scales. You walk through cities with towers and streets that seem immense, yet compared to these cosmic centers, every human structure is less than a grain of dust. Imagine standing on a planet orbiting within such a galaxy, knowing that far away, at the core, a black hole rests, unseen but always present, shaping the orbits of everything around it. Its gravity is not a constant pull you feel, but a subtle influence that binds the galaxy into order, like a hidden weight holding a mobile in place. Astronomers cannot observe black holes directly, but their presence is revealed by what surrounds them. Gas clouds heat and glow as they spiral inward, jets of energy burst outward at near-light speed, and stars orbit with speeds too great to be explained otherwise. The famous images of black holes, rings of fire surrounding a dark center, are not portraits of destruction, but glimpses of balance, of forces at work where light itself cannot escape. There is something quietly humbling in knowing that every galaxy carries such a heart. Creation and consumption exist side by side, woven into the same structure. When you look at the night sky, you are not just seeing stars scattered across emptiness. You are also seeing the invisible centers that hold them, silent and patient, shaping the rhythm of the cosmos. Imagine yourself drifting through a vast cloud of dust and gas, so diffuse it looks like a soft veil across space. To the eye it seems calm, almost dreamlike, But within these nebulae lies turbulence. Gravity pulls unevenly, gathering material into knots that grow heavier with time. Collisions ripple through the cloud, waves of pressure squeeze gas tighter, and the once quiet expanse becomes restless. In those dense pockets, hydrogen atoms are pressed so close together that their boundaries blur, until at last nuclear fusion ignites. A star is born not gently, but in a sudden blaze of fire. Think of daily life, where birth is often imagined as tender, as the beginning of calm routines. Families cradle infants, communities gather to celebrate new life. Yet in the universe, birth is rarely peaceful. The arrival of a star is noisy in energy, if not in sound. Radiation pours outward, shock waves push against the surrounding cloud, carving new shapes and scattering material that may later form planets. What looks serene from Earth is in truth the result of storms far more powerful than any weather we know. Astronomers trace these births with telescopes tuned to infrared and radio light, peering into dark nebulae where visible light cannot escape. They see filaments of gas twisting, collapsing, and flaring, each one a cradle of future suns. Some will grow stable, shining for billions of years. Others will flare quickly, massive and short-lived, destined to burn out in cosmic instants. The cycle is continuous. Chaos to fire, fire to light, light to ashes, and ashes back to clouds again. Imagine yourself standing beneath the night sky, the stars above you no longer just points of light but survivors of violence. Each calm twinkle carries the memory of turbulence, of dust compressed into fire. To see them is to glimpse both serenity and struggle, a reminder that even beauty can be born of upheaval, and that creation, in its largest scales, begins not in silence but in storms. Imagine yourself walking through a forest without clearings, each tree giving way to another, no edge, no border, only repetition stretching beyond what you can see. The universe may be like this, without walls or endings, extending endlessly in every direction. If space has no edge, then the galaxies we observe are only a faint sampling of an infinite whole. In such a reality, there would be not just billions, but endless galaxies, endless stars, and perhaps endless worlds like Earth. Infinity is not simply vastness. It is a concept that dissolves boundaries altogether, leaving no final horizon. Scientists speak cautiously of this possibility, for infinity is difficult to prove. What we know is that the observable universe is finite, bound by the reach of light across time. Yet beyond that horizon, space could continue forever, repeating patterns we will never touch. If matter is distributed without limit, then the combinations of particles that form you, me, and everything we know might repeat too. Somewhere, unimaginably far away, there could be another Earth, another version of yourself sitting quietly, perhaps wondering the same thing. To imagine infinity is to confront both wonder and unease. It suggests that uniqueness is fragile, that every moment may be echoed endlessly elsewhere. Yet it also places us inside a grand symmetry, a vastness where our small lives are woven into patterns beyond imagination. Infinity is not loud or overwhelming. It is silent, patient, unending. As you let this idea drift across your thoughts, notice how it softens the edges of certainty. There may be no end, no final point, only the gentle repetition of stars and galaxies, layered forever. Like ripples spreading without shore, the universe reminds us that what feels singular may be part of something without limit, quietly repeating into eternity. The sun feels eternal, a steady light rising each morning, but in truth it is a star with a limited lifespan. At roughly 4.6 billion years old, it has already lived through half of its natural cycle. Astronomers call this the main sequence, a long period when a star steadily fuses hydrogen into helium, maintaining balance between the inward pull of gravity and the outward push of energy. Our Sun is comfortably settled in this stage, quietly burning, with around 5 billion years left before its next transformation. Imagine yourself in ancient times, when people first looked upward and wondered if the sun could ever fade. To them it must have seemed infinite, a fire beyond all measure. Today, science has given a different picture, not of endlessness, but of endurance. The sun's life is vast compared to our own, yet finite, its story unfolding at a pace too slow for any single human generation to sense. This Middle Age is a time of stability. The sun continues to provide the steady warmth and light that make life possible, while subtle changes occur over millions of years. Gradually, it grows brighter and hotter. A billion years from now, Earth's climate may no longer resemble the world we know, oceans slowly evaporating under an ever more intense sky. Yet for now, in this brief moment of cosmic history, it offers a rare equilibrium, a star neither too young nor too old, but balanced in its prime. When we say the sun is middle-aged, we place ourselves in perspective. Our lives unfold in a blink compared to its long span. Civilizations rise and fall, yet the sun's daily rhythm continues, a silent reminder of both our fragility and our place within something larger. It is a companion in time, already ancient, yet still with billions of years to shine before its light begins to dim. Imagine yourself standing beneath the night sky, looking at stars spread across a vast canvas. It feels endless, yet what you see may only be a fragment. Some theories suggest that our universe is not alone but one bubble among countless others, each expanding, colliding, or drifting apart in ways we cannot observe. If true, the cosmos we know, its galaxies, its physical laws, even the flow of time, might be only one version of reality, with others existing side by side, unreachable yet real. In daily life, the thought is distant. You sip water, feel gravity hold you to the ground, watch sunlight trace its path across familiar hours. But in another universe, gravity might be stronger, stars might burn out too quickly, or atoms might never form at all. Imagine a place where light behaves differently, or where time moves in unpredictable rhythms. These worlds would be alien beyond recognition, and yet, according to some models of physics, they may be as natural as our own. The idea emerges from attempts to explain why our universe seems so finely balanced. Tiny changes in the strength of forces or the weight of particles could have made life impossible. In the multiverse view, it is not that our universe is special, but that many exist, and we happen to live in the one where conditions allow us to ask the question. Some scientists point to the inflationary model of the Big Bang, suggesting that as space expanded, it might have spawned countless pocket universes, each sealed off from the rest. No telescope can yet confirm this. The evidence is hidden beyond horizons we cannot cross. Still, the thought lingers. The stars above may not mark the edge of everything, but only the boundary of what we can see. Beyond, reality itself may repeat in endless variations, each one a silent possibility waiting in the dark. Imagine the moon hanging silent in the sky, its face pale and still, a lantern frozen in time. To the eye it seems lifeless, its craters unchanged for millions of years, its volcanic fire long extinguished. Yet beneath that calm surface, the moon still stirs. Seismometers left by Apollo astronauts revealed that it trembles with moonquakes, subtle but persistent. Some are caused by the pull of Earth's gravity, stretching and flexing the lunar crust. Others arise deep within, echoes of stresses that have not yet faded. The moon, though cold and ancient, is not entirely still. In daily life we think of the ground as stable, yet even Earth reminds us that solidity is an illusion, shifting and groaning beneath our feet. The moon, too, carries this hidden restlessness. Imagine standing in a crater under a black sky, stars unblinking above. The ground vibrates softly, almost imperceptibly, a reminder that even a body thought long dead carries a pulse. These quakes can last for hours, their energy traveling through rock in ways that hint at structures deep below the surface. Perhaps fractured layers, perhaps reservoirs of stress locked since its fiery youth. Astronomers study these tremors not just as curiosities, but as guides. Moonquakes reveal the moon's interior, the thickness of its crust, the composition of its mantle, the possibility of molten pockets that linger like fading embers. For future travelers, these quakes matter too, since their strength could affect fragile bases or equipment. In a world that appears frozen, they are signs of motion, subtle reminders that stillness can deceive. There is comfort in this thought. Even in silence, life and motion persist. The moon may seem like a relic, but it continues to breathe in its own way, long after its heart grew cold. When you look up at its familiar face, remember that beneath the stillness, it quietly trembles, carrying echoes of a restless past into the present. Imagine yourself walking through a familiar street. Buildings rise, trees sway, people pass by, and everything feels solid, certain, visible. Yet physics whispers that all this, every atom in every stone, leaf, and heartbeat, is only a fragment of what exists. Ordinary matter, the kind that shines, reflects, and builds worlds, makes up just 5% of the universe. The rest is hidden. Dark matter, which exerts gravity but cannot be seen, and dark energy, an even stranger force that drives the universe to expand faster and faster. Think of daily life where the unseen still shapes experience. The wind bends trees though it remains invisible. Emotions shift the course of human actions though they leave no physical mark. In a similar way, galaxies spin too quickly for their visible stars alone to hold them together. Something unseen, dark matter, anchors them like a hidden scaffolding. And the very space between galaxies stretches wider with time, as if some silent hand, dark energy, is pushing it outward. Astronomers measure this not by sight but by effect. They trace the bending of light around galaxies, the motions of stars, the accelerating drift of distant clusters. All reveal the same truth. Most of the universe is concealed, not absent but unlit, operating beyond the senses. For centuries, people trusted what eyes could see, the surface of oceans, the fire of stars. Now we know sight tells only part of the story. Imagine yourself beneath the night sky, every star a brilliant point of certainty. Yet around and between them lies the greater part, invisible and quiet, shaping everything without revealing itself. To live in this universe is to accept that what is seen is only a fraction, and that the vast majority of existence is hidden. The cosmos itself reminds you that mystery is not an absence of truth but the fabric of reality, surrounding every visible thing. Imagine the life of a star as a long, steady flame. For billions of years, it burns quietly, balancing gravity pulling inward and nuclear fusion pushing outward. Yet most stars, including our Sun, do not end with a dramatic explosion. Instead, when their fuel is finally spent, they fade into something smaller, quieter, more delicate. These remnants are called white dwarfs, faint, cooling embers of once brilliant stars. A white dwarf is no larger than Earth, yet it holds the mass of a sun. Its matter is compressed into extraordinary density, glowing at first with residual heat, then slowly dimming over billions of years. Unlike a supernova that announces an ending with violent spectacle, this is a gentle decline, a slow surrender of light. If you imagine standing beneath such a sky, you would not see fire and chaos, but a star gradually growing fainter until only silence remains. Our sun will follow this path. It will swell into a red giant, shed its outer layers, and leave behind a glowing white dwarf at its core. This remnant will shine for eons, a reminder of the star that once warmed worlds and shaped their histories. Across the galaxy, most stars take this same journey, ending not in destruction, but in endurance, a long twilight that stretches into near eternity. There is a quiet comfort in this destiny. The universe is not only written in explosions and collapse, but also in slow fading, in embers that linger long after the fire. And as you let the thought settle, you might imagine yourself drifting with these faint stars, glowing softly, holding memory in silence, waiting patiently as time itself moves on. When we think of an explosion, we imagine a single point of origin, a center from which everything flies outward. It would be natural to picture the universe that way, expanding from some central spot into surrounding emptiness. Yet, in truth, the universe has no middle. The expansion discovered by astronomers in the last century is not like shrapnel from a blast, but more like the stretching of a fabric, where every thread moves away from every other. Imagine a balloon being inflated, with dots drawn across its surface. As the balloon grows, each dot sees all the others move away, yet none of them sits at the center. The surface itself has no preferred point. Expansion is everywhere at once. In a similar way, galaxies drift apart not because they are flying through space, but because space itself is stretching between them. From any vantage point, on Earth, on a distant world, or in another galaxy entirely, it would appear as though the universe is expanding outward from you. This is part of why astronomers describe the cosmos as homogeneous and isotropic. On the largest scales, it looks roughly the same in all directions, without edges or privileged locations. There is no cosmic north, no absolute middle, no spot to mark as the beginning. Instead, the universe carries its history within the motion of galaxies, the faint afterglow of the Big Bang, and the quiet unfolding of expansion. For daily life, this truth is difficult to feel. You wake beneath the same sun, walk familiar paths, and the ground seems fixed beneath you. Yet, in reality, everything is moving. Your body carried on Earth's orbit, Earth carried within the Milky Way, and the galaxy itself carried within the silent flow of expansion. There is no center, only motion without anchor, every point equally part of the whole. Imagine yourself listening not with ears but with the fabric of reality itself. In the deep silence of the cosmos, two black holes may circle each other, locked in a slow spiral. For millions of years, they drift closer, their immense gravity pulling them into a tightening dance. When they finally collide, the violence is beyond imagining, yet no light escapes to mark the moment. Instead, the universe shudders. Ripples in spacetime, gravitational waves, spread outward, carrying the signature of their union across billions of light-years. In daily life, you would never notice these tremors. They pass through you, through mountains and oceans, stretching and squeezing space itself by amounts smaller than an atom. And yet, with delicate instruments, scientists have learned to listen. In 2015, detectors first caught the faint signal of two black holes colliding, their masses several times greater than our Sun. The sound, translated into human hearing, was like a brief chirp, a tiny note that told a story of cosmic giants merging in the dark. Such collisions are not rare in the grand scale. Galaxies themselves often merge, and within their centers, black holes are drawn together. Over time, pairs become one, forming even larger objects that continue to shape the structure of the universe. Imagine the invisible chain reaction, each collision stirring spacetime, each ripple carrying a memory of that hidden event, a record written not in light but in motion. The idea that the universe has its own background music, subtle, patient, almost inaudible, changes how we see it. The stars above may shine brightly, but beneath their glow lies a quieter truth. The cosmos does not only shine, it resonates. And in that resonance, every collision reminds us that even the darkest places are never truly silent. Imagine a galaxy, its spiraling arms glowing with billions of stars, each one blazing like a tiny sun. To the eye, the galaxy seems complete within that luminous boundary, a disk of light set against the dark. Yet what you see is only part of the story. Surrounding every galaxy is an immense, invisible halo of dark matter, an envelope so vast it stretches far beyond the outermost stars. These halos cannot be seen or touched, but their gravity is undeniable, shaping the way galaxies move, holding them together across billions of years. In daily life, you know the comfort of things unseen. The air you breathe, the gravity that anchors your steps, the quiet threads of memory that shape who you are. A galaxy's halo is much the same, present though imperceptible, giving structure without ever revealing its face. Astronomers trace these halos by studying the speed of stars at a galaxy's edge. The stars move too quickly to be held by visible matter alone, so there must be more, an unseen mass cocooning the galaxy, a silent partner in its existence. Imagine yourself drifting far beyond the edge of the Milky Way. The bright disk fades behind you, but you are not outside it yet. The halo extends outward, immense and diffuse, a sphere of influence so wide it dwarfs what light can show. Entire dwarf galaxies orbit within it, like small fish circling in a vast and hidden sea. Though you cannot see the dark matter, you are still within its grasp, still bound to the galaxy's silent pull. There is something humbling in knowing that every shining star, every glowing nebula, floats inside an unseen structure far greater than itself. The visible universe is only the surface, a thin layer resting within invisible scaffolding. When you look at the night sky, you are not only seeing galaxies as islands of light, you are also glimpsing their hidden halos, vast and quiet, surrounding them like shadows too immense to measure. Imagine yourself watching the first light of dawn creep across the horizon. The sky brightens, colors shift, and the sun seems to rise in real time. Yet what you see is not the present but the past. Every sunrise is already 8 minutes old, for light takes that long to travel from the sun to Earth. The rays that warm your face began their journey minutes before you felt them, streaming across the empty stretch of space at nearly 300,000 kilometers per second. Think of daily life, where timing shapes routine. Farmers rise when the light first touches their fields, travelers once set sail by the position of the sun, and children still measure the day by its climb and fall. Yet none of them saw the sun as it truly was in that moment. The star they trusted for rhythm and order had already shifted, its light delayed by the very distance that makes life possible. Even your heartbeat, warmed in the morning, beats slightly behind the reality of the sun. Astronomers often extend this thought further. The farther you look into space, the older the light you see. The moon's glow is already a memory 1 second old. The nearest stars shine with light that left years ago. Galaxies appear as they were millions of years in the past, silent archives carried by photons across time. The night sky is not a picture of now, but a layered history written in light. Imagine yourself standing beneath that sky, knowing that even the familiar warmth of the sun is not immediate but delayed. Every golden beam carries the story of travel, of distance crossed, of time stretched. To live on Earth is to dwell in echoes, where light itself is always a messenger from the past, arriving just late enough to remind you that even the present moment is never fully present. Imagine standing at the edge of the sea, watching waves roll endlessly toward the shore. It feels as though water has always been here, shaping coastlines, filling rivers, nourishing life. Yet Earth was not born with oceans. In its earliest days, our planet was a searing sphere of molten rock, too hot to hold liquid water. The seas we now take for granted likely arrived later, delivered from the silent dark of space. Scientists believe icy comets and water-rich asteroids bombarded Earth billions of years ago, carrying frozen reservoirs that melted upon impact, pooling slowly into the basins of a cooling world. Each drop in the ocean may once have been ice drifting between planets, a fragment of ancient dust bound in deep cold. Over time, these deliveries built rivers, lakes, and eventually the vast oceans that cover most of Earth today. Chemical fingerprints in seawater hint at this cosmic origin, suggesting that our planet's life-giving water was not an inheritance of birth but a gift from beyond. To think of this is to realize how fragile and rare such a process may be. Worlds without such bombardments remain barren, dry, silent. Earth is different not because it was destined to be, but because chance and collision filled it with liquid possibility. The oceans we swim in, sail across, and depend upon are, in a sense, borrowed from the stars. As you let the thought drift, picture the ocean not just as water, but as history. Cosmic ice melted into tides, celestial fragments turned to waves. Every ripple against the shore carries an echo of deep space, a reminder that even the most familiar parts of our world may have traveled across billions of miles before finding a home here. When a meteorite falls to Earth, it may look like nothing more than a dark stone, scarred from its fiery passage through the atmosphere. Yet within its weight lies something extraordinary, a fragment of the solar system's earliest history. Most meteorites are billions of years old, older than the planets themselves, formed from the raw material that once swirled around the newborn sun. They are time capsules, carrying traces of the conditions from which Earth and all its neighbors first emerged. Imagine holding one in your hand. Its surface feels rough, its interior dense, sometimes flecked with tiny metallic grains or crystals. These features are not accidental. They are records. Some meteorites preserve chondrules, small, glassy spheres formed in the searing heat of the early solar nebula. Others contain organic compounds, complex molecules that may have once played a role in the origins of life. Each fragment tells part of a story written before there were oceans or continents, before even the moon had taken shape. Throughout history, people have looked at falling stars with awe and fear, sometimes seeing them as omens. In truth, what streaks across the sky is the visible end of a long journey, begun far from here. Some meteorites come from the asteroid belt, leftovers of planetary construction. A few have even been traced to Mars or the Moon, flung into space by impacts and carried across interplanetary distances before finally arriving on Earth. Scientists study these stones carefully, slicing them thin, measuring their isotopes, reading their chemistry like a diary. What they find is often humbling: evidence of water locked in minerals, or clues to the violent collisions that shaped the young solar system. To hold a meteorite is to touch deep time itself. It is a reminder that the universe is not only above you in the sky, but sometimes lands quietly at your feet, offering pieces of its hidden past. Imagine yourself in a quiet room, the air still, every sound hushed. Now imagine that silence stretching across the cosmos. Even here, in the deepest calm of space, there is a faint background hum, not of sound but of light. It is the cosmic microwave background, the afterglow of the Big Bang, a whisper of radiation left behind when the universe was young. More than 13 billion years ago, the cosmos was a hot, dense fireball. As it expanded, it cooled, and light that once blazed freely was slowed, stretched into microwaves that now drift through space like a soft, invisible mist. Daily life carries no hint of this. You cook, walk, speak, all without feeling the quiet sea of photons flowing through you. Yet with the right instruments, scientists can detect it from every direction, no matter where they point their antennas. In fact, in the 1960s, 2 engineers stumbled on it by accident. They thought the faint static in their radio dish was caused by dust or even nesting birds, until they realized it was something far older, a message from the dawn of time. This glow is astonishingly uniform, yet it holds tiny ripples, minute differences in temperature and density that became the seeds of galaxies and stars. Imagine looking at a faded painting, almost erased by age, and finding in its faint brushstrokes the blueprint of everything to come. That is what the cosmic microwave background represents, a fragile record of the universe's first breath, preserved across eternity. Even now, those echoes surround you. They are not loud or bright, but they endure, a constant reminder that the universe remembers its own birth. Every time you look at the night sky, you are not only seeing stars, but also bathed in the light of beginnings, a soft and ancient glow still lingering from the first moment of creation. Imagine standing on the surface of a distant moon, its landscape cold and glimmering beneath the faint light of a faraway sun. Here, volcanoes exist, but they do not roar with fire. Instead, they whisper with frozen breath. On worlds like Enceladus, a moon of Saturn, volcanoes erupt not with molten rock but with plumes of ice and water, sprayed high into space. From the darkness of a frozen crust, geysers burst forth, glittering like pale fountains against the black. It is a volcano, but remade by cold, sculpted not by fire but by silence. Daily life teaches us to imagine volcanoes as destructive, mountains glowing with lava, ash falling like rain. Yet on these distant moons, eruption means something different. Imagine walking across a plain of ice, the ground creaking beneath your steps, and then seeing a sudden spray of frozen crystals rising into the void, delicate as frost. These ice volcanoes or cryovolcanoes reshape their world slowly, spreading layers of frozen material that glisten under starlight, softening surfaces we once thought lifeless and still. For scientists, these eruptions are more than wonders of geology. The jets of Enceladus contain salts, organic molecules, even hints of liquid oceans hidden beneath the crust. Through these icy plumes, we glimpse the possibility of environments where life could emerge, sheltered far from sunlight yet warmed by hidden energy deep inside. The same cold landscapes that appear barren may be among the most promising homes for life beyond Earth. There is comfort in this paradox, that even in the most frozen places, motion and possibility persist. Volcanoes do not always burn. Sometimes they freeze, carrying whispers of oceans and perhaps of life itself. When you look toward Saturn's faint ringed glow, remember that one of its tiny moons breathes through icy fountains, reminding us that the universe is not only fire and stone, but also silence and frost. Imagine yourself standing beneath a night sky, tracing the faint glow where Jupiter shines like a steady lantern. To the eye, it is simply another planet, distant and quiet. Yet without it, Earth's story might have ended countless times. Jupiter's immense gravity acts as a guardian, drawing in comets and asteroids that drift dangerously through the solar system. Many of the objects that could have struck Earth are captured, deflected, or swallowed by this giant long before they approach our skies. Think of daily life where guardianship is often unseen. A city wall keeps danger outside while life continues within. A lighthouse bends storms and rocks into safe passage for ships. Families share bread without ever speaking of the hands that protected the harvest. In the same way, Jupiter stands at a distance, its shield invisible but constant, allowing Earth's fragile ecosystems and civilizations to grow in relative peace. Astronomers trace scars on Jupiter's atmosphere, dark marks where comets have plunged into its storms, reminders of dangers diverted from elsewhere. The most famous was in 1994, when fragments of comet Shoemaker, Levy 9 collided with Jupiter, leaving bruises larger than Earth itself. Each impact testifies to Jupiter's role as both magnet and shield, a silent absorber of blows that might otherwise have ended oceans, forests, and human history in an instant. Imagine yourself walking through an ordinary day, sharing a meal, reading in quiet, listening to the rhythm of your own breath. These moments exist partly because of a planet you may never see clearly, one that keeps watch at the edge of night. Jupiter does not choose to protect, yet its gravity bends fate, shaping the path of worlds. The calm you inherit is, in part, a gift from a giant storming far away, a reminder that even safety is written in the vast mechanics of the cosmos. Imagine watching a star at the end of its life, expecting the final curtain to fall in one brilliant act. Most massive stars collapse only once, ending as a supernova, an explosion so powerful it outshines galaxies for a brief moment. Yet in rare circumstances, nature writes a stranger script. Some stars unleash such violence that their collapse is not the end, but a pause. These rare giants, known in theory as hypernovae, can explode, collapse inward under their own weight, and then reignite, exploding a second time with unimaginable force. The first explosion sends shock waves racing outward, scattering elements across space. But the star's immense mass does not give way easily. Its core collapses again, pressed into new extremes of density. For a moment, gravity and energy wrestle in silence, until instability triggers a second detonation, even more powerful than the first. To us, across light years, this would appear as an extraordinary burst of brightness, a flickering finale unlike the steady decline of ordinary stars. These double deaths are not just spectacles. They are forges of rare elements, scattering the building blocks of planets and life into interstellar clouds. Without such violent endings, the universe would lack many of the heavy atoms that make Earth, and us, possible. To imagine this is to glimpse the paradox of endings that are never simple. Stars can die twice, their echoes written across the galaxy in light and matter. And as you let the thought linger, you may notice how even in collapse, the universe finds ways to release brilliance again, quietly reminding us that some finales arrive not once, but in layers, like fading notes repeating softly through the halls of time. In daily life, sound is constant. The rustle of leaves, the murmur of voices, the hum of machines, it is almost impossible to imagine existence without it. Yet beyond Earth's thin atmosphere, sound disappears. Space is not filled with air or water to carry vibrations. It is a vacuum, and in that emptiness, waves of pressure cannot travel. No explosion can roar, no star can hum, no collision echoes beyond its own point of impact. Deep space is a vast theater where light, not sound, is the storyteller. Imagine standing on the surface of the moon. A hammer strikes metal nearby, and though you might see the impact, you would hear nothing through the airless void. Only by touch, through the vibrations traveling up your arm or your suit, would you sense the event. This is why astronauts communicate by radio, not by voice carried through the space around them. Silence is the natural state of the cosmos. Yet it is not emptiness of experience. Instead of sound, the universe offers its messages through light and energy. Radio waves, X-rays, visible light, all travel freely through the vacuum, crossing vast distances that sound could never traverse. Telescopes become our ears, tuned to these signals, transforming them into colors, patterns, and even artificial tones we can perceive. In this way, silence itself becomes a kind of paradox. The most violent events in the universe, supernovae, black hole mergers, galaxies colliding, are utterly silent in their moment, yet blaze with radiation that we can detect across billions of years. Space is therefore both quiet and expressive, voiceless yet filled with communication. When you look up at the night sky, you are witnessing this silent performance. Stars shimmer, planets glow, nebulae spread their faint colors. The stage is vast, the actors brilliant, but the play unfolds in perfect silence, eternal and unbroken. Imagine yourself gazing into the darkness of a black hole, a place where gravity is so strong that nothing, not even light, can escape. It feels eternal, like the ultimate full stop of the cosmos. Yet some theories suggest black holes are not forever. Through a process called Hawking radiation, named after physicist Stephen Hawking, they may slowly leak energy, particle by particle, until they vanish completely. The edge of the event horizon is not silent. It flickers faintly with quantum effects, like whispers at the boundary between existence and nothingness. In daily life, the idea of something so vast shrinking into nothing is difficult to picture. You might imagine a mountain melting grain by grain, or a star dimming imperceptibly across generations. For black holes, the timescales are almost unthinkable. A small one might fade in a burst over billions of years, while a giant at the center of a galaxy could take longer than the current age of the universe to disappear. Yet in theory, the end is the same. Even the mightiest collapse may one day dissolve into pure energy. What would that finale look like? Scientists suggest the last stage could release a final outburst, a sudden flash of radiation as the black hole evaporates. No one has ever observed such an event, but the possibility lingers in equations, like a secret coded into the fabric of physics. It reminds us that nothing, not even a black hole, is truly permanent. For now, they remain, shaping galaxies and bending light, silent titans of the cosmos. But somewhere, in the deep arithmetic of the universe, their endings are written. Imagine them not as endless prisons of gravity, but as slow-burning candles, destined one day to flicker, flare, and finally vanish into the quiet sea of space. Imagine a star that has already died, collapsing under its own weight until it becomes something unimaginably dense. What remains is a neutron star, a body so compact that a teaspoon of its material would outweigh mountains. Some of these remnants spin at extraordinary speeds, turning dozens, even hundreds, of times each second. As they rotate, they send out beams of light and radiation, sweeping across space like the steady flash of a lighthouse guiding ships at sea. To an observer far away, the light appears in pulses, on, off, on again, marking the presence of what we now call pulsars. In daily life, you might think of clocks, they're ticking a constant rhythm that measures time. Pulsars are like cosmic clocks, their beams arriving with such regularity that astronomers use them as tools to map space itself. Imagine listening to a signal so precise that it hardly drifts even over millions of years, a beacon in the silence of the universe. The pulse becomes a reminder that order can exist within chaos, that even the debris of a violent stellar death can become a source of steady rhythm. Astronomers first discovered pulsars in 1967, when radio telescopes picked up unusual signals repeating with perfect consistency. At first, some wondered if the source might be artificial evidence of communication. But soon the pattern was understood as natural, though no less remarkable. Since then, pulsars have guided us in understanding extreme physics, gravity, magnetism, and the limits of matter itself. There is comfort in imagining these distant lighthouses, spinning endlessly in the dark. They are reminders that even in the aftermath of destruction, the universe finds ways to create patterns of beauty and order. When you look at the stars above, hidden among them are these beacons, flashing silently, sweeping their light across the cosmos like signals meant to be found. Imagine yourself standing on solid ground, the earth beneath your feet feeling steady, unmoving, eternal. Yet far below, hidden beneath layers of rock and mantle, lies a heart of fire. Earth's core, made mostly of molten iron and nickel, burns at temperatures hotter than the surface of the sun, more than 5,000 degrees Celsius. You walk through days and nights unaware that beneath every step, a blazing sphere churns and roars in darkness, powering the planet's magnetic field and shaping the very conditions that make life possible. Think of daily life, where heat is contained in small, familiar forms, a hearth warming a home, an oven baking bread, a forge glowing red. Ancient blacksmiths believed their fires were unmatched, yet the earth itself carries a furnace far greater, hidden in silence. That unseen heat drives the movement of continents, lifts mountains over ages, and fuels the eruptions of volcanoes. The rhythm of human lives, fields planted in fertile soil, cities built on shifting ground, is tied to this restless interior. Scientists study it indirectly, for no one can travel so deep. They listen instead to seismic waves, like physicians reading a pulse, tracing how vibrations move through layers of rock. From this, they know the inner core is solid, pressed to metal hardness by crushing pressure, while the outer core is liquid, swirling in vast currents. These currents create Earth's magnetic shield, a silent protector that deflects solar winds and preserves the air we breathe. Without that shield, oceans and life itself might have vanished long ago. Imagine yourself beneath the open sky, feeling the cool air on your skin. Beneath you, far below, that hidden fire still burns, a reminder that stability is an illusion. Earth is alive with inner storms, a silent engine turning endlessly. Every quiet step you take rests upon a furnace greater than any human fire, a heart of iron that has never stopped beating since the world began. Imagine stepping back far enough to see the universe not star by star, but in its entirety. From that vantage, galaxies are not scattered randomly like grains of sand. Instead, they trace vast patterns, aligning along invisible threads of gravity. This is the cosmic web, an immense structure stretching across billions of light-years, where galaxies gather along filaments of dark matter and empty voids open like vast hollows in between. What looks chaotic from our small perspective reveals itself, at scale, as a woven fabric, intricate and interconnected. Astronomers discovered this pattern by mapping thousands of galaxies, their positions forming long strands that stretch and branch like veins or roots. Clusters emerge where filaments intersect, enormous nodes where countless galaxies gather, drawn together by gravity's pull. Between these strands lie dark spaces, voids nearly empty, hundreds of millions of light-years wide. The result is something organic in appearance, as though the universe itself were shaped like a living organism. In this structure lies history. The cosmic web grew from the faint ripples in the early universe, tiny variations in density amplified over billions of years. Dark matter, unseen but dominant, sculpted the scaffolding, while gas and stars filled the threads. To trace these patterns is to glimpse how galaxies are not solitary, but part of a greater design, bound into a network that transcends any single world or cluster. As you let your mind wander across this image, picture the night sky not as scattered points but as part of a hidden architecture, each star and galaxy a bead on a thread in a vast web. It is a reminder that even the largest scales of the cosmos hold quiet order, and that what seems empty is often filled with patterns too large to see until you step back far enough. When you walk along a shoreline, sand slips between your fingers in endless measure. Each grain seems countless, yet scientists suggest the stars of the universe surpass even this abundance. On every beach of Earth combined, the number of sand grains is vast beyond calculation, and still the cosmos holds more suns. Astronomers estimate there may be around a septillion stars, that is a 1 followed by 24 zeros, spread across billions of galaxies. Imagine standing by the sea, waves rolling in steady rhythm, the beach stretching far beyond sight. The sand beneath your feet is ancient, weathered fragments of stone. Each grain, small as it is, has a history of mountains crumbled and rivers worn down. Now think of each star as another grain, scattered not across a shore but across an ocean of space. From every point in the sky, the numbers extend outward, unreachable, almost without end. This perspective is not meant to overwhelm but to remind us of scale. The night sky that seems so sparsely dotted hides depths we cannot see unaided. Between the familiar constellations are billions more stars, too faint, too far, yet still part of the whole. In truth, the visible sky is only a thin surface of a far richer fabric, each point of light a distant sun with its own potential worlds. To compare stars with sand is less about measurement than about wonder. It draws a bridge between the small and the vast, between something we can touch and something we can only imagine. The grains beneath your feet and the stars above your head both belong. Imagine yourself looking at the night sky, filled with stars scattered like sparks across a dark canvas. They seem eternal, but they are only temporary lights in an expanding universe. If this expansion never stops, if galaxies continue drifting farther apart, the cosmos may face an ending known as the heat death. Paradoxically, it is not heat but the absence of it, a slow fading into uniform cold, where energy is spread so thin that nothing new can ever form. Daily life offers no glimpse of this distant future. The sun still rises, seasons still turn, and the rhythm of life continues. Yet on cosmic scales, stars exhaust their fuel, one by one. Galaxies lose their structure as gravity can no longer hold them together. Over trillions of years, even the last red embers of starlight will fade. Imagine a sky with no constellations, only a darkness unbroken, as though the universe itself had exhaled its final breath. Physicists describe a future where black holes remain the last architects of structure. They too would eventually evaporate, leaving only faint radiation. What lingers after is a thin sea of particles, evenly spread, with no gradients to drive change. Time itself would continue, but with nothing left to measure it against. It would be existence without events, a vast stillness. The thought is not meant to stir dread, but perspective. The universe that gave rise to stars, planets, and life is also writing its own conclusion. You, here and now, inhabit a fleeting moment between beginning and end, when light still fills the skies. Beyond you stretches an immensity destined to fade, not in fire or destruction, but in silence, an ending so quiet it almost feels like rest. Imagine the moon, familiar and constant, its same face always turned toward Earth. For centuries people have spoken of a dark side, as though half the moon were locked in eternal shadow. Yet this is a misconception. The far side, hidden from our eyes, receives just as much sunlight as the side we see. It is not dark, only unseen. The moon is tidally locked, meaning its rotation matches its orbit, so the same hemisphere faces us always, while the other remains turned away, rising into day and falling into night in the same rhythm. In daily life, we often assume that what we cannot see must be absent. A closed door hides a room, a wall blocks a view, and our minds imagine silence or emptiness behind them. The moon teaches a gentler lesson. Unseen does not mean unlit. If you stood on its far side, the sun would still rise over the horizon, casting long shadows across cratered plains, lighting ridges and valleys in the same pale glow we know from Earth. The cycles of day and night play out there just as they do here, steady and unbroken. Astronomers first glimpsed the far side in 1959, when a Soviet spacecraft sent back photographs. What they found was not darkness but a surface marked by rugged mountains and deep craters, different from the smoother seas we see from Earth. Later missions revealed its hidden history, showing how impacts shaped it in ways distinct from the near side. Science turned mystery into understanding, yet the quiet allure remains. There is comfort in this revelation. The universe holds truths that are not as they seem. The far side of the moon is not a place of shadow but of balance, illuminated in equal measure, simply hidden from our constant gaze. When you look upward, remember, the unseen is not the unloved, and what lies beyond sight may be shining all the same. Imagine yourself looking up at the night sky, where galaxies shimmer faintly like scattered islands of light. At first glance, the universe seems still, each star in its place. Yet astronomers discovered something stranger. The cosmos is not only expanding, it is accelerating. The more space grows, the faster it stretches, carrying galaxies farther apart with each passing moment. What is near today drifts away tomorrow, and in the far future, many galaxies will slip beyond sight, their light stretched until it can no longer reach us. Think of daily life, where growth often slows with time. Children grow quickly but steady as they age, harvests peak and then decline. The universe defies that rhythm. Its expansion quickens, as though distance itself learns to run faster the farther it travels. This acceleration is powered by a mysterious presence called dark energy, a force that pushes space itself outward. No one sees it, no one feels it, yet it shapes the destiny of everything. Astronomers measure this using distant supernovae, stellar explosions that act like cosmic mile markers. Their faintness revealed the universe was expanding faster than expected, a finding so startling it earned a Nobel Prize. And the paradox remains. Gravity should slow the universe, yet something stronger urges it outward, an unseen hand that no law fully explains. Imagine yourself centuries from now, standing beneath the same sky. The familiar constellations may remain, but beyond them, the grand spirals and clusters that fill today's telescopes could vanish from reach, racing too far into the dark. To live in such a universe is to realize that what you see is temporary, that the night sky itself is a changing story. Every star and galaxy you glimpse tonight is part of a fleeting window in cosmic time, a reminder that expansion is not gentle drift but an accelerating tide, carrying creation further from your eyes with every passing breath. Imagine skies where storms do not bring water, but glittering stones. On Neptune and Uranus, deep within their dense atmospheres, the immense pressure and heat can transform carbon into diamonds. Molecules of methane are broken apart, their carbon atoms compressed until they crystallize, forming solid jewels. These crystals then fall through the atmosphere like rain, sinking into layers hidden far below. What on Earth is rare and precious becomes, in these distant worlds, a natural weather pattern, diamonds cascading like hail in storms no human eye has seen. Scientists have recreated this process in laboratories, compressing carbon under conditions that mimic these planets. Their experiments suggest that diamonds may not only form, but accumulate in vast layers, oceans of solid gems stretching across planetary interiors. Over time, the diamonds could even sink toward the core, creating glittering mantles buried under crushing weight. It is a reminder that beauty in the universe often hides where we cannot reach, in places both alien and magnificent. To think of diamond rain is to feel the strangeness of cosmic diversity. On Earth, diamonds are symbols of permanence, carved by time from carbon deep in the crust. On Neptune and Uranus, they are ephemeral, forming and falling endlessly, common as drops of rain. The contrast is humbling. What we cherish most can be, elsewhere, nothing more than weather. As you let this image linger, picture the skies of those planets. Dark, cold, silent, broken only by the shimmer of crystals tumbling downward. It is a vision at once alien and strangely familiar, a storm of beauty that belongs not to Earth, but to the quiet, glittering heart of the outer solar system. A black hole begins simply enough, matter collapsing under its own weight, gravity growing stronger as the core shrinks smaller. But at a certain point, gravity becomes absolute. Once past the event horizon, the invisible boundary surrounding a black hole, nothing can return. Not light, not matter, not even information. What falls in is cut off from the rest of the universe, as though erased from the story of space and time. Imagine standing at the edge of such a horizon. To you, the fall would seem swift, a crossing into darkness. But to an outside observer, time itself appears to slow. Objects nearing the horizon seem frozen, light stretched into red and fading away. This is the paradox of black holes. What is real in one frame may vanish in another, and certainty itself begins to unravel. Physicists struggle with what this means. If information truly disappears into a black hole, it contradicts the laws of quantum mechanics, which insist information is never lost. This information paradox has become one of the deepest puzzles in modern physics. Some theories suggest information is somehow preserved on the horizon itself, like a hologram etched into the fabric of space. Others propose it escapes subtly through Hawking radiation, though no one knows how this would work. In daily life, such concepts feel remote. Yet they carry profound weight, hinting that the very rules of reality may bend at the edges of black holes. Are they cosmic vaults, locking away all traces of what enters? Or are they mirrors, reshaping and releasing information in ways we cannot yet see? What remains certain is that black holes are not just objects but boundaries, places where our understanding falters and where the universe keeps its most profound secrets. Imagine yourself beneath a clear night sky, watching stars burn with quiet steadiness. They seem unchanging, as if they have always been there and always will be. Yet every star, no matter how bright, carries a limit. Their glow is powered by nuclear fusion. Atoms fuse together in their cores, releasing light and heat. When the fuel runs out, the star's balance collapses. Gravity, always patient, takes over, and the star must face its ending. In daily life, endings are familiar. A candle burns down, a fire cools to ash. Stars follow the same truth on scales too vast for us to see. Smaller stars, like our Sun, will swell into red giants, shedding their outer layers until only a dense white dwarf remains, slowly fading over trillions of years. Heavier stars live more dramatically, burning through fuel quickly before collapsing and exploding as supernovae. From those violent deaths may come neutron stars, cores so compressed that a teaspoon would outweigh mountains, or black holes, regions where gravity allows nothing to escape. Astronomers study these remnants as records of cosmic life cycles. Nebulas, glowing clouds of gas from dying stars, seed new generations of suns and planets. The iron in your blood, the calcium in your bones, the oxygen you breathe were forged inside ancient stars that no longer exist. Imagine the quiet legacy of those vanished lights, their deaths woven into your very being. The night sky you see is filled with stars in every stage of life, some just forming, some steady in their prime, and some already gone, their light still traveling toward you. To know stars are not forever is not to diminish them, but to understand that endings are part of the rhythm of the universe. Their brilliance lies not in eternity, but in the brief, magnificent chapters they write across the dark. Imagine looking deep into the night sky, far beyond the reach of naked eyes, to places where light has traveled for billions of years to arrive. Among the faint specks of galaxies, astronomers find objects so bright they can outshine everything around them. These are quasars, distant beacons powered not by stars, but by black holes. At the center of young galaxies, supermassive black holes feed on gas and dust, drawing matter inward at such speed that it heats to extreme temperatures, glowing with a brilliance greater than entire galaxies combined. In daily life, brightness is tied to scale, a city glowing at night, a single lamp illuminating a dark room. But quasars bend this intuition. Imagine a black hole, something that lets no light escape, becoming the source of the brightest objects we know. Around it forms an accretion disk, spiraling streams of gas compressed and heated until they blaze across the universe. To us, that light is a message from the distant past, arriving long after the galaxy itself has changed or faded. Quasars were first discovered in the 1960s. their signals appearing strange, like stars but with unusual spectra. The name itself, quasi-stellar radio source, reflects the early confusion. Yet with time, astronomers understood them as galaxies in their youth, their central black holes growing and feeding in a way that made them shine with unimaginable power. Today, they are markers of the early universe, helping us trace how galaxies formed, grew, and changed over cosmic time. There is something humbling in this paradox, that the darkest objects, black holes, can be surrounded by light so overwhelming it travels billions of years and still reaches us. When you look into the sky, faint as it seems, hidden within are quasars burning brighter than entire galaxies, reminders that even in the farthest reaches, brilliance can emerge from silence. Imagine yourself stepping outside on a calm morning. You breathe deeply, the air cool and invisible, so ordinary you rarely notice it. Yet this thin blanket of gases, nitrogen, oxygen, and trace elements, is the only thing standing between life and the endless vacuum of space. Earth's atmosphere is fragile, stretching only a few hundred kilometers above the surface, thinner than the skin of an apple compared to the planet it surrounds. Without it, oceans would boil away, sunlight would scorch unfiltered, and every breath would vanish into silence. Think of daily life where protection is often unseen. A roof keeps out the rain, walls hold back the wind, clothing shelters against cold. People rarely stop to consider these coverings, yet without them comfort and survival would collapse. The atmosphere is Earth's greatest covering, shielding life from radiation, burning meteors before they reach the ground, and keeping warmth from fleeing into the void. Ancient farmers relied on seasonal rains carried by this air, sailors trusted winds to guide their ships, and today every breath you take is part of this fragile gift. Scientists describe it in layers: the troposphere, where clouds form and weather moves; the stratosphere, where the ozone absorbs ultraviolet light; and higher still, wisps of gas so thin they barely cling to Earth. Satellites and astronauts orbit within this tenuous veil, skimming the edge where air fades into space. From above, it looks like a faint blue line wrapped around the globe, delicate as glass, easily broken in appearance yet vital to every moment of life below. Imagine yourself under the night sky, stars shining beyond a dome of unseen air. You live inside this invisible shield, carried by it with every breath, every word, every quiet pause. The atmosphere is not endless, not unshakable, but fragile, an unseen thread that keeps Earth alive, reminding you that even the smallest layer can hold the weight of an entire world. Imagine looking up at Saturn, its rings glimmering like delicate glass suspended in space. To us, they seem eternal, the planet's most defining feature, a perfect crown of ice and dust circling endlessly. Yet astronomers now know the rings are not permanent. Slowly, particle by particle, they are falling into Saturn, pulled by the planet's gravity. What appears so steady is, in truth, a fleeting structure, one that will one day vanish completely. The process is called ring rain. Microscopic fragments from the rings are caught in Saturn's magnetic field and dragged into its atmosphere, dissolving in clouds far below. Measurements suggest that the rings may disappear in just tens of millions of years, a blink in cosmic time. To human perspective, they will endure far longer than any civilization. But to the universe, they are temporary ornaments, destined to fade. The rings themselves are thought to be relatively young, perhaps only 100 million years old, formed when comets or icy moons were torn apart by Saturn's pull. Their brightness is a clue. Older rings would have darkened with cosmic dust, but Saturn's remain brilliant, fragile, almost new. To know that they will vanish is to see them differently, not as a permanent crown, but as a fleeting spectacle caught between creation and collapse. As you let the thought settle, imagine Saturn in the far future, bare and unadorned, its skies quiet without their shimmering bands. What seems eternal in the night sky is only passing through its own story. The beauty of Saturn's rings lies not in their permanence, but in their impermanence, a reminder that even the most majestic wonders drift toward silence. Every star has an origin, and our sun is no exception. It was not born alone, but within a cluster, an immense nursery of gas and dust where many stars formed together. Roughly 4.6 billion years ago, the Sun ignited among thousands of siblings, all born from the same collapsing cloud. In those first millions of years, the young cluster may have been dense and bright, its stars crowded close enough to shape one another's paths. But with time, gravity pulled them apart. The cluster dispersed, its members scattered into the wider galaxy, until the Sun was left adrift, unaccompanied. Today, we cannot point to the place where the Sun first emerged. The stars that once shared its cradle have wandered across the Milky Way, hidden among the countless billions of other suns. Astronomers search for them still, using chemistry as a kind of fingerprint. Stars born together share similar compositions, subtle patterns in their elements that reveal a shared origin. Somewhere, perhaps many light-years away, the Sun's lost siblings still shine, invisible to us in the crowd. Imagine what it would mean to find them. A twin star, born in the same nursery as our own, drifting now on the far side of the galaxy. Perhaps some carry planets of their own, worlds that evolved under skies not so different from ours. In this sense, the Sun's story is not just solitary. It is part of a larger family, scattered but connected by memory. In daily life, the Sun feels central and self-contained, but its true history is communal. It began in company, in a crowded birthplace now erased by time. To look for its siblings is to trace the lost chapter of our own beginnings, hidden somewhere in the great, quiet sweep of the Milky Way. Imagine yourself tracing the arc of time, from the Big Bang to the expanding universe around you. It feels like a story with a beginning and perhaps an end. Yet some theories suggest the cosmos may not stop at a single ending. Instead, after expanding for billions of years, gravity could one day pull everything back together. Galaxies would drift closer, stars would collide, and all of space would shrink toward a final collapse known as the Big Crunch. Out of that collapse, a new explosion might ignite, another Big Bang, beginning the cycle again. In daily life, the idea of collapse followed by renewal is familiar. Forests burn and regrow, rivers flood and reseed, generations pass and rise again. The universe may echo this rhythm on a cosmic scale, never truly ending, but reshaping itself endlessly. Imagine all the stars and matter compressed into a single point, only to burst outward once more, scattering seeds for new galaxies, new stars, perhaps even new lives. This theory is not certain. Evidence today points toward continued expansion, driven by dark energy, which may prevent collapse. But still, the notion of a cyclical universe lingers in science and philosophy alike. Ancient myths spoke of eternal returns, of worlds destroyed and reborn, and physics offers a similar possibility. The end of one universe may simply be the hidden beginning of another. To think of the cosmos this way is to imagine a reality without finality, where endings are never truly endings, only transformations. The stars above, the ground beneath you, even the flow of time may belong to a pattern repeating across eternity. The universe, then, is not only vast but patient, writing and rewriting its story forever, each cycle an echo of the last. Imagine a black hole, that silent place where gravity grows so strong even light cannot escape. To most, it seems like an end, a point of no return where matter vanishes forever. Yet some theories suggest something stranger, that black holes may not be endings at all, but possible gateways. In certain models of physics, the immense gravity could curve space in such a way that it links not just distant points in our universe, but perhaps other universes entirely. These speculative passages are called wormholes, imagined as tunnels connecting realities. In daily life, we are used to doors and corridors, paths that lead from one room into another. The wormhole idea borrows this sense of passage, applying it to the fabric of space-time itself. Imagine yourself stepping through an ordinary doorway and finding not another room, but an entirely different world. To the mind, it is difficult to grasp, yet to the equations of relativity, such a possibility is not impossible. The very black holes we picture as devouring may, under the right conditions, also conceal openings. Astronomers have no direct evidence for these cosmic connections. Black holes behave as expected. They pull, they consume, they radiate faint signals as matter spirals inward. But the idea of wormholes has persisted for decades, partly because it offers an elegant bridge between what we observe and what might exist beyond. Science fiction has kept the image alive, ships passing through luminous tunnels, travelers moving instantly across unimaginable distances. Reality may never offer such ease, but the mathematics leaves the door open. There is something soothing in the thought that what looks like an end could also be a beginning. Perhaps every collapse is not only destruction, but also transition, an unseen passage leading elsewhere. When you look at the night sky and imagine black holes, remember that some may not be silent graves but hidden connections, linking realities in ways we can only dream. Imagine yourself watching the moon rise, its pale glow steady against the darkness. To the eye, it seems only a companion, circling Earth in quiet rhythm. Yet the moon does far more than light the night. Its gravity steadies Earth's spin, holding the planet's axis at a gentle tilt of about 23 degrees. Without that anchor, Earth would wobble wildly, its poles and equator shifting over ages, and the rhythm of seasons would collapse into chaos. Think of daily life where stability allows routine. Farmers plant by cycles of spring and harvest, children grow into patterns of school and rest, families gather by traditions tied to seasons. All of these depend on the balance of Earth's tilt, which governs warmth and cold, day length and growth. Without the moon's pull, the axis might swing dramatically, tilting steeply one age, flattening the next. Winters could stretch into centuries, summers vanish without warning, and climates shift too fast for life to adapt. Astronomers trace this truth through models and ancient records. Planets without large moons, like Mars, bear scars of instability, their tilts wandering over time, leaving climates unpredictable. Earth, by contrast, has enjoyed long stretches of balance, long enough for forests, oceans, and civilizations to flourish. The moon, born from a colossal impact in the planet's infancy, became not just a satellite but a stabilizer, a quiet architect of habitability. Imagine yourself beneath its silver light, knowing it does more than mark tides and time. Every breath you take, every steady rhythm of life, unfolds under its influence. The moon is not simply decoration in the sky, it is the reason seasons return, the reason Earth's spin is calm, the reason life as you know it could find stability. A silent guardian, turning endlessly above, shaping the balance of the world below. Imagine holding a piece of gold in your hand, its weight cool and steady, its shine seemingly eternal. It feels like something deeply of earth, mined from stone, carried through rivers, shaped by human hands. Yet its true origin lies far beyond our planet. Gold, along with platinum, uranium, and other heavy elements, was not born here at all. These metals were forged in the violent deaths of giant stars, created in the crushing heat and pressure of supernovae and neutron star collisions. Every fragment of jewelry, every trace of uranium in rock, every platinum wire is a relic of cosmic violence, scattered across space and gathered here by chance. The process is called nucleosynthesis. Ordinary stars, like our Sun, fuse hydrogen into helium and build lighter elements like carbon and oxygen. But to form heavier atoms requires far more extreme conditions. When a massive star dies, its core collapses and its outer layers are blasted outward in a supernova. In that brief moment, energies surge so violently that atomic nuclei are forced together into the heaviest of elements. In rarer cases, when two neutron stars collide, entire streams of gold and platinum are forged and cast into the galaxy. Over billions of years, these stellar ashes settled into the clouds of gas and dust that eventually formed our solar system. Earth inherited them in its rocks and oceans, and humanity later uncovered them, shaping them into currency, art, and tools. To wear a golden ring or hold a silver coin is, in truth, to touch the remnants of stars. As you let the thought linger, imagine the quiet paradox: beauty born from destruction, permanence born from collapse. The rarest treasures of Earth are the whispers of ancient stars, fragments of light that once died so the universe could be built anew. For most of human history, the universe was seen as a grand machine of matter and motion, operating under physical laws. But in recent decades, some thinkers have pushed this image further. They suggest the cosmos itself might be a kind of simulation, not simply obeying rules, but generated by them. In this view, stars, galaxies, even the fabric of space and time could be outputs of an underlying code, woven into existence by principles we cannot yet perceive. Imagine walking through your day. Light bends around objects, time flows at its familiar pace, the world feels solid beneath your feet. Yet beneath that solidity, could everything be information? Just as numbers on a screen create images and patterns, perhaps the laws of physics are the visible surface of a deeper program. The constants of nature, the speed of light, the charge of the electron, the strength of gravity, might be written parameters, values selected in ways we cannot explain. Some physicists compare this idea to the holographic principle, where all the information within a region of space could be encoded on a boundary surface. Others wonder if the discreteness of quantum mechanics, the way particles jump between states rather than flowing smoothly, resembles the steps of a computation. Even the vast structure of the universe, with galaxies arranged in filaments and voids, has been likened to the patterns of neural networks or digital simulations. Of course, no evidence proves this view. It remains a philosophical speculation, a mirror turned toward our own methods of understanding. We build simulations to test reality, and in turn, imagine reality itself as simulation. Whether or not the universe is literally code, the metaphor lingers, reminding us that existence may not be as straightforward as it appears. In the silence of deep space, you are left with a question. If reality is a program, who, or what, pressed the first key? Imagine yourself holding a globe in your hands, its smooth surface suggesting a flawless sphere. It feels natural to think Earth is shaped the same way. But the truth is subtler. Earth spins on its axis, and that rotation makes the planet bulge slightly at the equator. Instead of being a perfect sphere, it is an oblate spheroid, flattened a little at the poles, stretched gently around the middle. The difference is small, only about 43 kilometers wider across the equator than from pole to pole, but enough that the Earth you live on is more like a softly squashed ball than a perfect globe. Daily life offers no hint of this distortion. To your eye, horizons appear straight, oceans curve gently, mountains rise and fall. But satellites tracing orbits must account for the bulge, and navigators for centuries relied on careful measurements to map Earth's true form. Even Isaac Newton predicted it. He reasoned that a spinning planet could not remain perfectly round. Later, expeditions confirmed it, measuring arcs of the meridian in distant lands and showing the planet's polar flattening was real. This subtle imperfection shapes the world in quiet ways. The bulge influences ocean currents and winds, nudges satellites, and even shifts how gravity feels depending on where you stand. At the poles, you are slightly closer to Earth's center and weigh a bit more. At the equator, farther out, a touch lighter. Imagine the planet beneath your feet not as a flawless sphere, but as something dynamic, marked by the rhythm of its own spin. The image of Earth from space, round and blue, remains iconic. Yet behind that beauty lies a reminder. Perfection is rarely found in nature. The Earth you inhabit carries its own subtle asymmetry, not a flaw but a reflection of motion, a world shaped not into stillness, but into movement. Imagine sitting quietly, listening to the steady tick of a clock. Each moment feels distinct, one following another, forming what we call time. Yet some physicists suggest this flow may be an illusion. What we experience as time might not exist in any absolute sense, but instead is a framework the mind uses to make sense of change. In the equations of physics, past, present, and future can appear equally real, as though the universe is a block where every moment already exists, layered together beyond our perception. From this perspective, your life is not a line moving forward, but a landscape, every memory and every possibility already present, like pages in a book. What we call now is simply the point your consciousness happens to be reading. The sensation of time passing may be more about the way our brains record and process change than about the structure of reality itself. In deep space, where clocks tick differently under the pull of gravity, the illusion becomes even clearer. Time is not fixed, but bends and stretches, revealing its fragility as a concept. Philosophers have wrestled with this for centuries. Augustine once wrote that he knew what time was until he tried to explain it. To imagine time as unreal is unsettling, yet also strangely comforting. If the present is only a perception, then perhaps every moment still exists, every smile, every loss, every forgotten hour, woven permanently into the fabric of the universe. As you let this idea linger, consider the possibility that change is real, but time is only the name we give to its rhythm. The universe may not be flowing forward at all, but simply existing, complete and silent, while our minds drift across it like travelers tracing a path that was always already there. When we picture a galaxy, we imagine a glowing spiral or a faint smudge of light, billions of stars gathered together. Yet not all galaxies shine. Astronomers suspect that many may drift unseen, made mostly of gas and dark matter, with little or no starlight to reveal their presence. These are sometimes called dark galaxies, vast structures without the brilliant beacons we normally associate with galactic life. The idea first emerged as scientists studied the rotation of galaxies. The speed at which stars orbit suggested far more mass existed than could be explained by what was visible. Dark matter, unseen but gravitationally real, became part of the picture. Extending this logic, entire galaxies might exist where dark matter dominates and star formation never fully took hold. Instead of glittering spirals, they would be silent clouds, detectable only by their faint gas or by the way they bend light from more distant objects. A few candidates have been found. One is known as Virgo 21, a massive cloud of hydrogen gas in the Virgo cluster. It rotates like a galaxy but shows almost no stars. Another, Dragonfly 44, appears to be made of 99% dark matter, a ghost of a galaxy with almost no visible light. These discoveries hint that the cosmos may contain many more galaxies than we can see, hidden in plain sight. Imagine the night sky if such galaxies glowed like ordinary ones. The heavens would be even more crowded, filled not with darkness but with overlapping halos of light. Instead, they remain invisible companions, drifting silently alongside the luminous galaxies we know. Their existence reminds us that much of the universe is concealed. What shines is only part of the story. What is hidden may be far greater. In this sense, the cosmos is like a book read by candlelight, its brightest words visible, its deeper pages waiting in the dark. Imagine the sun not as a steady, glowing sphere, but as a restless star, its surface roiling with storms. At times, immense bursts of energy erupt outward, solar flares and coronal mass ejections, sending streams of charged particles racing through space. To the eye, these events are invisible across the great distance, but their effects can reach Earth with startling force. A powerful enough storm could overload satellites, disrupt navigation, and cripple power grids, plunging entire regions into silence and darkness. History offers quiet warnings. In 1859, the Carrington event, the largest recorded solar storm, lit up the skies with auroras seen as far south as the Caribbean. Telegraph systems sparked and failed, operators shocked by currents racing through their wires. Today, with our deep reliance on electronics, the impact of such an event would be far greater. Communication networks, GPS, internet connections, even water and food distribution systems, all could falter under the weight of a storm carried on solar winds. Yet solar flares are also part of the natural rhythm of a living star. They rise and fall with the sun's 11-year activity cycle, reminders of the dynamic heart that fuels our world. Most pass with little consequence, brushing against Earth's magnetic field like gentle waves against a shore. It is only the rare, massive storms that hold the potential to reshape daily life. As you let this thought drift, imagine Earth as a small vessel under a vast, fiery tide, protected most of the time, yet always vulnerable to a storm that could arrive without warning. The sun gives us light, warmth, and life, but in its restless brilliance lies the reminder that even our most constant companion carries power beyond measure. Most planets spin upright, their poles tilted only slightly, giving them regular days and seasons. Uranus, however, is different. It does not rotate like a top, but rather like a ball rolling on its side. Its axis is tilted by about 98 degrees, so extreme that it appears to have been tipped over completely. As it circles the Sun, it carries this sideways posture, making it unlike any other planet in our system. Astronomers believe a colossal impact may explain this tilt. In the early solar system, collisions were common, and a glancing strike from a massive body could have knocked Uranus off balance. The evidence lingers in its strange orientation, as though it still remembers the ancient blow that redefined its motion. Instead of upright spinning, it rolls, its poles pointing nearly directly at the Sun during parts of its orbit. Imagine the seasons on such a world. For decades, one hemisphere faces the Sun constantly, bathed in unbroken light, while the other lies in a deep, frozen night. Later, the situation reverses, leaving Uranus with seasons that last not months, but 21 years at a time. Its atmosphere, pale blue-green from methane gas, drifts under this unusual rhythm, with winds and storms shaped by cycles unlike anything on Earth. This sideways rotation also affects its magnetic field, which is tilted and offset from its core, producing complex, shifting patterns. Spacecraft flying past Uranus have detected this strangeness directly, confirming that the planet's inner structure may be as unusual as its outward spin. Among the planets, Uranus reminds us how diverse worlds can be. It shows that even in the same solar family, histories diverge, and one collision can tilt an entire world into a lifetime of sideways motion. Imagine yourself standing in warm sunlight, feeling its gentle heat on your skin. It seems immediate, as though the rays that reach you were born only moments ago. In truth, the light shining on you today began its journey thousands, even hundreds of thousands of years ago. Deep inside the Sun's core, atoms of hydrogen are pressed together under immense pressure, fusing into helium and releasing energy. But this energy does not stream out freely. Instead, it begins a long, meandering path, scattering from particle to particle, taking an extraordinary amount of time to reach the surface. In daily life, we measure time in days, seasons, and years. Yet inside the Sun, time stretches differently. A single photon of light may wander for tens of thousands of years before it escapes the dense interior. Only then does it break free, traveling the final 93 million miles to Earth in just over 8 minutes. Imagine the contrast, a journey of ages within the Sun, followed by a swift crossing through space. This delay means that the warmth you feel on your face is not from energy newly made, but from light that began its journey long before human history as you know it. Civilizations have risen and fallen while those photons were still trapped, bouncing endlessly through the solar furnace. Each beam of light carries with it a hidden history, a story of patience written into its long passage outward. When you look at sunlight glinting on water or filtering through leaves, you are witnessing something both ancient and immediate. It is a reminder that what feels present is often the product of deep, unseen time. The sun shines steadily, yet every ray you see is a message from the past, a fragment of energy that began its journey long before you ever looked up to greet it. Imagine drifting too close to a black hole, drawn across its invisible boundary, the event horizon. From a distance, nothing unusual seems to happen. Yet in that instant, the rules of the universe shift. Gravity at your feet would pull far harder than at your head, the difference so extreme that your very body would be stretched into impossibly thin strands. Scientists call this process spaghettification, a name almost whimsical for something so absolute. Matter, whether rock, star, or human, would be unraveled into atomic threads, woven into the fabric of the black hole's darkness. This is not destruction in the way we usually imagine it. Instead of shattering, matter is elongated, pulled outward until it loses any shape it once had. The force is so relentless that even the strongest bonds of atoms cannot resist. Imagine steel twisted like soft cloth, planets stretched like strands of silk. Once past the horizon, all paths lead inward, compressed eventually into the singularity, a point where density and gravity reach limits we cannot yet comprehend. And yet, spaghettification is not chaos but order, the natural consequence of gravity's gradient applied to its most extreme degree. The stretching follows precise laws, predicted by Einstein's theory of relativity. To study it is to realize that the strangest fates in the cosmos are not random but inevitable, written into the very equations that govern space and time. As you let this thought rest, picture the quiet paradox, that in falling apart, matter reveals its deepest structure, reduced to threads finer than imagination. Beyond the event horizon, there is no return, no witness, only the silent unraveling of form. What seems bizarre, even comical in name, is in truth one of the most profound transformations the universe can offer, ordinary matter becoming strands of infinity. When we think of galaxies, we imagine permanence, vast islands of stars that endure for billions of years. Yet not all galaxies remain whole. Some fade, dissolve, or are stripped apart, leaving only fragments behind. To an observer, it can seem as though a galaxy has vanished, its once bright presence reduced to faint trails of stars stretched across the void. This happens most often in crowded regions of space, such as galaxy clusters, where giants pull on their smaller companions. A dwarf galaxy drifting too close to a larger neighbor may be torn apart by tidal forces, its stars scattered like grains of dust. Gas, the fuel for new stars, can be stripped away as well, leaving behind only a dim, skeletal remnant. Over time, the galaxy ceases to shine, its identity erased within the larger whole. Astronomers have discovered ghostly evidence of these disappearances. Long arcs of stars stretch between galaxies, marking the paths of former systems pulled apart. The Sagittarius dwarf galaxy, for instance, is in the process of being consumed by our own Milky Way, leaving faint streams of stars that wrap around the sky. To us, they appear as delicate traces, but they are the footprints of a galaxy slowly dissolving into another. There are also cases where entire galaxies seem to dim mysteriously. In 2015, scientists observed a cluster where a massive galaxy once shone, only to find it gone years later, replaced by a faint haze. Whether it was stripped, merged, or hidden behind dust remains uncertain. To imagine galaxies disappearing is to see the universe not as fixed, but as ever-changing. Just as mountains erode and rivers shift on Earth, galaxies too are reshaped, sometimes to the point of vanishing. What remains are trails and echoes, reminders that even on cosmic scales, nothing lasts unchanged. Imagine yourself gazing at the night sky, each star a steady point of light against the dark. They seem isolated, each one burning alone, but in truth they are connected in cycles far older than human memory. Stars are not eternal. They live, they die, and from their remains, new stars are born. When a star exhausts its fuel, it may shed its outer layers or collapse in a violent supernova. The gases and heavier elements it once forged in its core spill into space, seeding the galaxy with raw material. In daily life, endings feel final. A candle burns out, a tree falls and decays. Yet in the cosmos, endings create beginnings. The iron in your blood, the calcium in your bones, the oxygen you breathe were all formed in stars that no longer exist. Their ashes became clouds of dust and gas, which later collapsed under gravity's pull to form new suns, new planets, and eventually, life itself. Imagine a vast recycling process, galaxies as great workshops where nothing is truly wasted, only transformed. Astronomers study nebulae, the glowing remnants of dead stars, as nurseries of creation. Within them, dense knots collapse into new stars, while planets gather from surrounding disks of dust. Through telescopes, we see these clouds illuminated in colors, red, blue, green, silent testaments to stellar lives ending and beginning again. They are the bridges between death and rebirth, between destruction and renewal. The stars you see tonight may one day enrich future generations of worlds. Their light will fade, but their matter will not be lost. It will be woven again into new constellations, new galaxies, and perhaps even new lives. The universe, it seems, has always known how to take what has ended and begin again. Imagine standing in a field with no horizon, no edge, only a silence that seems endless. When we speak of the universe expanding, the mind instinctively wants to know, expanding into what? The human sense of space comes from boundaries. A room has walls, a city has edges, even an ocean is framed by coasts. Yet the cosmos is not a balloon drifting into empty air, nor a bubble swelling into some greater void. It creates space as it stretches, weaving new fabric where none existed before. In this sense, expansion does not require a container. It is the act of existence generating more of itself. You might imagine a grid drawn on a sheet of rubber. As the rubber stretches, the points grow further apart, but the sheet itself does not float within a larger canvas, it simply is. This idea is difficult to hold on to, because we live in a world of boundaries. Ancient thinkers once imagined the heavens as crystalline spheres encasing the earth, each layer turning with stars and planets embedded in them. Later, as telescopes revealed an endless sky, the question of limits returned. Was there a wall beyond the stars? Was there an outside? Today's cosmology answers with a quiet paradox. There is no outside to move into. The universe does not expand into space, it expands space itself. Galaxies drift apart not because they are flying through something larger, but because the distances between them are stretched by the growth of the cosmic fabric. The night sky you see is not a static dome, but a pattern continuously drawn farther apart. Imagine yourself holding 2 grains of sand on an inflating balloon. To your eye, the grains seem to drift away from one another, though neither is moving across the surface. They are carried by the expansion of the surface itself. Now extend that thought into 3 dimensions. The galaxies are not traveling into emptiness. The emptiness unfolds from within. And so, the phrase, expanding into nothing, is misleading. It suggests a stage beyond the curtain, when in truth there is no stage at all. The universe is not rushing forward to fill a waiting vacuum. Instead, the vacuum itself is created in the act of expansion. The rhythm of existence is to open more room for itself, without ever needing a boundary. This thought can feel unsteady, but also strangely calming. In the end, the universe does not ask for edges to contain it. It only asks to keep unfolding. Imagine yourself standing on a shoreline, watching the tide roll in as countless generations before you have done. The rhythm of the waves feels eternal, yet beneath this timeless motion, something subtle has been changing: the length of Earth's day. Our planet's rotation is not fixed. Over millions of years, Earth has been gradually slowing down, making each day slightly longer than the one before. The difference is so small it slips past unnoticed in daily life, just a fraction of a second added over centuries, but when stretched across geological time, it becomes significant. Long ago, in the age of the dinosaurs, a day was closer to 23 hours. If you look even further back, to the early Earth, a day may have lasted as little as 6 hours. This gradual slowing is caused by the pull of the moon. Its gravity creates tides that drag against Earth's rotation, ever so slightly resisting the spin. The effect is gentle, but constant, like a hand brushing against a spinning wheel. You can think of it as a conversation between Earth and its satellite, an exchange of momentum that leaves traces in the passing ages. Scientists know this not only through theory but also through the fossils of ancient corals and shellfish. Their growth patterns are like natural calendars, recording the number of days in a year. These silent records show us that long ago, there were more days in each year because each day was shorter. For people in the past, daily life was shaped by the turning of the earth and the rising of the sun, yet they would not have sensed this hidden change. Farmers planted, sailors navigated, and priests marked rituals according to the heavens, never knowing that the very length of a day was slowly drifting. To us, the thought is both humbling and strangely comforting. Time, as we measure it, is not absolute. It bends, shifts, and stretches, just as the planet itself does. So the next time you glance at a clock, imagine all the unseen centuries where hours ticked a little differently, and the future millennia when days will stretch even longer, carrying forward the quiet rhythm of Earth's slowing spin. Imagine Mars as it appears today, dry, rust-colored, silent beneath a thin sky. Dust storms sweep across its barren plains, and its surface is carved with scars of ancient impact. Yet long ago, this world was different. Billions of years in the past, Mars held rivers that wound through valleys and lakes that shimmered under pale sunlight. Evidence lies in the dried channels still etched across its surface, the minerals that could only have formed in water, and the sediments layered like pages in a forgotten book. What we see now as a desert was once a place where water flowed freely. Scientists believe that Mars may have held oceans, vast enough to cover much of its northern hemisphere. Its atmosphere was thicker then, warm enough to keep liquid water from freezing or evaporating into space. For millions of years, cycles of rain and flow may have shaped a landscape not so different from Earth's, shorelines, deltas, and perhaps even waves that lapped against red sand. But the planet could not hold this gift forever. Mars's smaller size meant its core cooled quickly, its magnetic field faded, and without protection, the atmosphere thinned. Solar winds stripped it bare, and its oceans slowly vanished, leaving behind the silent desert we see today. The transformation was not sudden, but gradual, a slow unraveling of habitability. As you reflect on this, imagine standing at the edge of a Martian lake billions of years ago, watching sunlight glitter across the water. That scene is gone now, but its traces remain. Quiet reminders that worlds change, that oceans can dry, and that even the most desolate landscapes may once have held life's potential. The sun feels unchanging, rising each day with a steady glow. Yet, like all stars, it carries within it a finite clock. In about 5 billion years, its fuel of hydrogen will be nearly spent. The delicate balance between gravity pulling inward and fusion pushing outward will fail. Slowly, the sun will swell into a red giant, its outer layers expanding far beyond their current reach, possibly engulfing Mercury, Venus, and perhaps Earth. The skies of that distant future would burn with a vast, ruddy orb, a sight at once beautiful and devastating. But the red giant stage is only a prelude. As the outer layers drift away, they will form a luminous shell of gas, a planetary nebula, delicate and colorful when seen from afar. This nebula will expand outward, enriching the galaxy with material forged in the sun's core, carbon, oxygen, and other elements that may one day seed new worlds. What remains at the center will be small but dense, a white dwarf no larger than Earth, glowing faintly with the heat of what once was. Imagine standing on some future world, circling far from this remnant. The sun, once fierce and life-giving, would appear as a pale ember, shining with quiet persistence. It will no longer generate energy through fusion, but will slowly cool, radiating away the memory of its former brilliance. For trillions of years, it will fade further, until even its faint glow disappears into darkness. This ending is not destruction but transformation. The sun's death is part of a larger rhythm, where stars live, burn out, and pass on their materials to new generations. In this sense, the sun's burnout ensures continuity, for from its ashes, new stars and planets may one day emerge. Imagine yourself reaching out to touch the world around you, the solidity of stone, the weight of water, the warmth of sunlight on your skin. All of it feels immediate and real. Yet some theories in physics suggest that this reality may not be the full story. According to the holographic principle, the three-dimensional universe you experience could be a kind of projection, its information encoded on a distant, two-dimensional boundary. Like a hologram etched onto glass, the depth you see and feel may emerge from data stored on a surface you can never touch. In daily life, this thought feels impossible. You walk streets, eat food, hear voices, and it all carries texture and weight. But imagine discovering that every detail, the pull of gravity, the sparkle of starlight, the flow of time itself, could be a translation of information from a deeper layer of reality. What you know as space might not be fundamental at all, but a shadow cast by something beyond. The idea grew from attempts to solve puzzles about black holes. Physicists realized that the information of everything falling into a black hole might be preserved, not inside, but across its surface. If that principle applies to the cosmos itself, then the universe as a whole may work the same way. You may be moving through space, but in another sense, you could be reading from a hidden page, one where the script of existence is written. No telescope can yet reveal this deeper layer, and perhaps it never will. But the theory lingers, drawing together strands of quantum physics, gravity, and information. It reminds us that reality may be stranger than perception, that what feels solid might be a kind of illusion. Imagine then, as you look at the night sky, that the stars themselves could be part of a vast projection, an image cast from a reality just out of reach. Imagine yourself watching the night sky, tracing faint glows of galaxies that lie millions of light-years away. Each appears as a soft blur, a collection of stars too distant for your eyes to separate. Yet, hidden among them are objects far smaller, yet paradoxically far brighter. Black holes, often thought of as perfect prisons of darkness, can in certain moments outshine entire galaxies. Not because light escapes their grip, but because of what happens just before the fall. When matter drifts toward the event horizon, it does not plunge silently. Gas and dust spiral inward, forming a disk that circles faster and faster, compressed by gravity into heat and friction. In those final moments, matter shines, releasing energy so intense that it becomes visible across cosmic distances. You can imagine it as a whirlpool, not of water, but of stars and fragments of worlds. As the whirlpool tightens, temperatures climb to millions of degrees, producing radiation across the spectrum. To an observer, this storm of energy becomes a beacon, brighter than a galaxy filled with billions of suns. The paradox is clear. An object defined by its ability to let no light escape becomes known to us through its luminous hunger. Black holes are revealed not by their darkness, but by the brilliance of matter caught in their pull. Cultures once saw the night sky as eternal and unchanging. For them, stars were fixed lamps, steady and serene. Only later did astronomers notice faint points flickering with strange intensity, some pulsing, others glowing with unnatural brightness. These were quasars, among the most luminous objects in the universe, powered by supermassive black holes consuming matter at their cores. Imagine yourself standing in a desert night, the sky clear, and knowing that some of the brightest lights above you come not from stars, but from the edges of destruction. And yet, this energy is temporary. Once the surrounding matter is consumed, the light fades. A black hole without fuel becomes quiet, unseen, its presence detectable only through its gravity. There is comfort in that cycle. Moments of radiance, followed by long silences. The universe, in this way, repeats its rhythms, creation and consumption, brightness and darkness, without ever needing to hurry. Imagine yourself gazing at the night sky, each point of light seeming calm, eternal, and serene. Yet behind that gentle glow, some stars are far from peaceful. In hidden corners of the universe, stars can become cannibals, slowly consuming their stellar companions. These are not sudden explosions, but quiet acts of cosmic hunger. When two stars orbit each other in close proximity, the stronger one can pull matter from the weaker, stripping away gas layer by layer. Over time, one star grows bloated and radiant while the other withers into obscurity, its life stolen by gravity's relentless hand. Astronomers have found evidence of these stellar feasts through patterns of light and energy. As the cannibal star feeds, it often leaves traces, swirling disks of matter, or sudden flares as stolen material crashes onto its surface. In some cases, the victim star is not completely destroyed but slowly drained, like a candle melting into another's flame. Fossils of these events remain in the form of unusual stars, giants heavier than they should be, or faint white dwarfs that were stripped too soon. Each discovery reminds us that even among stars, survival is not guaranteed. For ancient cultures, stars were symbols of constancy. They guided journeys, marked seasons, and stood as metaphors for eternal light. To learn that some stars thrive by devouring others adds a quiet irony to this old belief. What seems fixed and eternal is, in truth, dynamic and sometimes ruthless. Still, there is a strange beauty in the cycle. From the ashes of these consumed companions, new cosmic forms emerge. Denser stars, richer chemical elements, and eventually, the seeds of planets and life. So the next time you look at the night sky, imagine that behind one of those calm, distant glows lies a hidden story of hunger, rivalry, and transformation, unfolding at a pace far too slow for the human eye, but written across the universe itself. Imagine the night sky, calm and steady, stars pinned in their familiar places. Yet hidden in the equations of cosmology is a possibility both strange and unsettling. The universe may not fade gently, but end in a sudden unraveling. This idea is called the Big Rip. It begins with the expansion of space itself. Today, galaxies are already drifting apart, carried by the steady growth of the cosmos. If the mysterious force driving this expansion, dark energy, were to grow stronger over time, the stretching would accelerate beyond control. At first, it would pull distant galaxies away, leaving each island of stars isolated in a sea of darkness. Then, as expansion quickened, it would tear apart the galaxies themselves, scattering stars from their clusters. Eventually, even solar systems could not resist. Planets would be unbound from their suns, drifting into emptiness. And still the acceleration would continue, reaching down into the smallest scales. Stars and planets would be torn apart, then molecules, then atoms, until nothing remained but scattered particles, flung outward into infinite separation. The timeline for such an ending is uncertain. If it happens at all, it lies billions or trillions of years ahead. To us, it is not an immediate threat, but a distant hypothesis, a reminder that permanence may be only temporary. For now, expansion is gentle, a quiet stretching of space, unnoticed in daily life. But in theory, the same process that makes the universe vast could also unmake it, unraveling structure at every level. As you let the thought settle, imagine existence itself as a woven fabric. The Big Rip is the possibility that one day, the threads will be pulled apart, not by fire or collapse, but by the silent persistence of expansion, stretching everything beyond recognition until nothing remains connected at all. Long before stars formed, before galaxies spun, the universe was a glowing sea of light and particles. As it expanded and cooled, that light stretched into faint microwaves, filling all of space. Today, we call it the cosmic microwave background, a relic of the Big Bang itself. It is everywhere, an invisible afterglow bathing the universe, reaching Earth from every direction. You have likely heard its echo without realizing it. When an old radio drifts off station, or when a television displays static, a small fraction of that hiss is not from the device at all. It is the whisper of the cosmos, a signal that has traveled for nearly 14 billion years. In the crackle of noise, you are brushing against the memory of the universe's first moments, when matter and light parted ways and the cosmos became transparent for the first time. Scientists first detected this radiation in 1965, quite by accident. Two engineers, working with a radio antenna, kept finding a persistent hum they could not eliminate. At first, they suspected faulty equipment, even nesting pigeons. But after careful checks, they realized the noise was universal, arriving from every patch of sky. They had stumbled upon the faint echo of creation. Since then, satellites have mapped this radiation in detail, revealing slight ripples, tiny variations in temperature that mark the seeds of galaxies yet to come. What began as uniform glow became the structure we see today: stars, planets, clusters, and life itself. Imagine this quietly. Every hiss of static, every faint whisper caught by an antenna, carries not just noise but history. The universe still speaks of its beginning, not in words, but in a soft background hum, always present, always surrounding you. Imagine yourself drifting above Jupiter's swirling clouds, watching storms the size of Earth roll endlessly across its surface. From such a distance, you might think it lives only on the light it receives from the sun, just as our own planet does. But Jupiter is different. It glows with heat of its own, radiating more energy than it absorbs. Deep inside, the giant still carries the warmth of its birth, when gravity pulled vast amounts of gas together, compressing it until it heated like a furnace. That primordial glow has never fully faded. In daily life, heat comes from familiar sources: fire, sunlight, the friction of movement. But Jupiter's warmth is the echo of formation itself, trapped for billions of years. Slowly, it leaks outward, rising through its thick layers of hydrogen and helium before escaping into space. The result is a faint but steady excess of energy, as if the planet remembers the moment it came into being. This hidden heat shapes what you see on the outside. Jupiter's atmosphere boils with motion, its great storms fed not only by sunlight but also by energy welling up from within. The Great Red Spot, a cyclone that has lasted for centuries, is one of many patterns born from this restless stirring. Imagine clouds shifting endlessly, driven by forces not only above but from the planet's deep, unseen heart. Astronomers compare Jupiter to a star that never quite ignited. It has the mass to glow faintly but not enough to spark nuclear fusion. Instead, it remains a glowing giant, a reminder of the boundary between planet and star. When you see it bright in the night sky, you are looking at more than reflected sunlight. You are witnessing a world still whispering with its original fire, a planet that has never fully cooled. Imagine stepping onto the moon, the surface calm and silent, the horizon wrapped in black sky. At first glance, the ground appears soft, like powdered ash, gentle underfoot. But lunar dust, or regolith, is nothing like the dust you brush from a shelf at home. It is jagged, microscopic shards, created not by wind or water but by billions of years of meteorite impacts shattering rock into glass-like fragments. Without weather to smooth its edges, each particle remains razor-sharp. Astronauts who walked the moon during the Apollo missions described how it clung stubbornly to suits, boots, and tools, embedding itself in every seam and joint. Static electricity, charged by the sun's radiation, made the dust behave almost alive, clinging tighter the more you tried to remove it. When astronauts returned to their lander and removed their helmets, they discovered something unsettling. The dust carried with them filled the air, irritating eyes, noses, and throats. Some described it as smelling faintly of gunpowder, though it was no familiar material at all. On Earth, lungs are fragile, and inhaling sharp-edged grains can lead to lasting damage. Prolonged exposure to lunar dust could be toxic, scarring tissues much like silica dust does to miners or construction workers. Imagine yourself breathing deeply, only to find the invisible particles cutting at the inside of your chest with every breath. The danger extends beyond health. The fine grains worked into seals and machinery, threatening to wear down critical equipment. NASA engineers worried that long-term missions might struggle not with lack of air or water, but with the persistent assault of dust. For future bases on the moon, solutions must be found. Airlocks designed to trap it, suits that never cross thresholds, systems to keep habitats clean. In the silence of the lunar surface, the greatest hazard may not be the vacuum above, but the sharp powder beneath your feet. Imagine yourself holding a simple compass, its needle steady, always pointing north. It feels like a symbol of certainty, something that never changes. Yet deep within Earth, even this quiet guidance is not permanent. Our planet's magnetic field is generated by molten iron swirling in the outer core, creating a protective shield around us. Over time, this magnetic field weakens, shifts, and, every few 100,000 years, flips entirely. North becomes south, and south becomes north. The process is not instant but unfolds chaotically, with magnetic poles wandering across the planet, sometimes splitting into multiple points before finally reversing. Geological records reveal this hidden history. In volcanic rock, tiny magnetic crystals lock in the direction of Earth's field at the moment they cooled. Layer by layer, they preserve a timeline of past flips, like silent pages of a diary stretching back millions of years. The last major reversal happened about 780,000 years ago. During these times, Earth's shield weakens, allowing more cosmic radiation to brush the surface. Yet life has endured through each reversal, adapting quietly to the shifting field. For ancient people, the sky and its patterns were a map of meaning, but they had no way of sensing that the very force guiding their compasses today has switched countless times before. Farmers, sailors, and travelers all relied on constancy, unaware that nature's foundation was moving beneath them. To us, this knowledge is both unsettling and strangely calming. Even the most enduring things, north and south, direction itself, are not fixed. They bend to the deep rhythms of the planet. So the next time you imagine following a compass needle, remember, it is not pointing to something eternal, but to a restless heart of molten iron, forever changing, forever rewriting the map of the world. Imagine standing beneath the night sky, watching countless stars flicker across the dark. Some of them have been burning for billions of years already, their light traveling immense distances just to reach your eyes. And most will continue to shine long after we are gone. Civilizations, even entire species, exist only briefly when measured against the lifespans of stars. A human life is a heartbeat. Even the rise and fall of empires is little more than a passing cloud. But stars endure, steady and patient, outliving all the histories written beneath them. Our own sun has burned for 4.6 billion years and will likely shine for another 5 billion before its fuel runs out. Smaller stars, red dwarfs scattered across the galaxy, burn even longer. Some will endure for trillions of years, living through ages we cannot comprehend. Against such vast spans, humanity's story is a moment, fragile and brief. The stars that watched the first humans gather around fire will still be present to witness whatever comes long after our future ends. This endurance is not loud or dramatic but quiet and steady, a rhythm that carries on regardless of what happens here on Earth. Wars, discoveries, cultures, and collapses all unfold under their patient glow. To imagine this is to feel a certain humility. The universe holds its course while our stories flicker quickly by. And yet, there is comfort in this perspective. The stars will remember for us. Even when we are no longer here to look up, their light will continue, shining across empty skies, carrying the memory of existence. In their endurance, we glimpse the continuity of the cosmos, a reminder that though we are brief, we are also part of something vast, something that outlives all endings. Black holes are often imagined as ultimate erasers, swallowing everything, matter, light, even information, so completely that nothing can return. Yet physics complicates this picture. According to quantum mechanics, information can never be destroyed. Every particle carries a record of what it once was, a history written into its state. If black holes truly erase that history, the very foundations of physics would fracture. This puzzle is known as the black hole information paradox. Some theories suggest the information is not lost but hidden, scrambled into forms we cannot yet decipher. One idea proposes that it lingers on the event horizon itself, encoded like a hologram across the black hole's surface. Another suggests it leaks out slowly in Hawking radiation, woven into the faint glow that black holes emit as they evaporate. To us, the pattern would be unreadable, like a book shredded and scattered to the winds, but still present in principle. Imagine standing near such a horizon. You watch matter fall inward, dust, gas, perhaps even the remains of a star. From your view, it seems to vanish, slipping into darkness. Yet in the mathematics, traces remain. Somewhere, somehow, the record persists, as if the universe refuses to forget its own story. This debate is not only about black holes. It touches on the nature of reality itself. If information is indestructible, then the universe is a kind of perfect ledger, keeping account of every event. If it can be destroyed, then our deepest assumptions about physics must be rewritten. For now, black holes remain silent on the matter. They keep their secrets hidden behind horizons, where gravity bends space and time too far for us to follow. What they truly do with the information they consume is still unknown, a riddle left at the edge of the cosmos. Imagine yourself watching a star in its final moments. For millions of years it has burned steadily, but once its fuel is gone, balance gives way to collapse. In an instant, the core folds inward, and the star explodes outward as a supernova. It is one of the most powerful events in the universe, outshining entire galaxies for a brief time. Yet in this destruction lies creation. The tremendous heat and pressure of the explosion forge heavy elements, iron, gold, uranium, that could never form under gentler conditions. These fragments are cast into space, drifting as dust and gas, waiting to be gathered again. Daily life carries traces of these ancient explosions. The metal in a ring on your finger, the oxygen in every breath, the calcium in your bones, all were born in stars that ended long before Earth existed. Imagine walking through a forest, realizing that every tree trunk, every stone, every living being carries the quiet memory of stars that once burned and died. You are, in a very real sense, the product of cosmic debris. Astronomers study nebulae, vast clouds that glow with the remnants of supernovae, as the cradles of new worlds. Within them, gravity slowly gathers matter, pulling together the seeds of future stars and planets. Solar systems are born from these ashes, each one carrying the chemical fingerprints of the generations before. The chain is endless. Stars die, elements scatter, and new worlds rise. When you look at the night sky, the light reaching you may come from stars already gone, their remains spread invisibly across the cosmos. Their deaths were not an ending but a gift, ensuring that future worlds, perhaps even future lives, could exist. Creation, it seems, is written into destruction, and every breath you take is proof that the universe knows how to begin again. Imagine yourself looking at the night sky, tracing the vast black canvas between the stars. From a distance, space feels smooth, infinite, and continuous, like an endless ocean without ripples. But some scientists wonder if this appearance is only an illusion of scale. Just as matter, once thought solid, was revealed to be built from atoms, space itself may not be infinitely divisible. Instead, it could be quantized, made of indivisible building blocks, sometimes described as atoms of geometry. These would be unimaginably small, far beyond the reach of microscopes, existing at the Planck scale, where distances are measured in fractions so tiny that our everyday intuition collapses. To imagine it, think of a photograph on your screen. From far away, it looks seamless. But if you zoom close enough, you see it is built of pixels, each a discrete square of color. In the same way, the smoothness of space might hide a deeper granularity, a hidden lattice on which the universe is woven. This is the realm where quantum mechanics and gravity collide, where the rules of the very small and the rules of the very large refuse to fit together neatly. The search for these fundamental quanta of space is part of the attempt to unify physics, to see whether the fabric of reality itself has a smallest stitch. The idea is not new. Ancient philosophers spoke of indivisible units, whether of matter, time, or space. Modern theories like loop quantum gravity or string theory explore similar possibilities, suggesting that geometry itself could come in discrete units. Imagine yourself moving through a room where every step, instead of being continuous, lands on invisible tiles too small for you to notice. To you, the movement feels fluid, but underneath there is structure, a rhythm hidden from ordinary sight. If true, the universe would not simply stretch infinitely fine. It would be underpinned by the smallest possible scale, a foundation that cannot be divided further. And while we may never touch or see these building blocks directly, the possibility invites a quieter reflection, that even the emptiest spaces are not empty at all, but constructed, bit by bit, from the most fundamental architecture of existence. Imagine yourself drifting in the silence of space, looking down at a small, pale world covered in ice. At first glance, it seems lifeless, frozen, barren, sealed under a shell of frost. Yet beneath that frozen crust may lie something astonishing, a hidden ocean. Moons like Europa, circling Jupiter, and Enceladus, orbiting Saturn, are thought to hold vast reservoirs of liquid water beneath their icy surfaces. Tidal forces from their giant planets flex and squeeze their interiors, generating enough heat to keep water flowing in darkness, trapped under layers of ice that may be miles thick. Scientists have found intriguing clues. On Europa, the cracked and ridged surface resembles shifting sea ice, as though currents below are slowly reshaping the crust. On Enceladus, geysers erupt into space, shooting plumes of water vapor and ice grains high above the surface. Instruments that passed through these plumes detected organic compounds, the building blocks of life, suggesting that these hidden seas are not just vast, but possibly rich with chemistry. To imagine oceans beneath ice is to imagine a secret world, silent and dark, yet restless with unseen currents. For us on Earth, oceans are places of life, mystery, and endless depth. Ancient sailors looked across their horizons and wondered what lived beyond. In much the same way, when we look at these frozen moons, we wonder what might stir in their hidden waters. Perhaps nothing more than salt and stone, or perhaps the beginnings of something alive, moving through the black depths far beneath the ice. The thought is quiet, humbling, and strangely comforting. Even in the coldest, most remote corners of our solar system, there may still be oceans, vast, secret reservoirs waiting patiently, carrying the possibility that life is not unique to Earth, but a quiet rhythm written across the universe itself. Imagine looking up on a clear night, watching a streak of light race across the sky. It feels sudden, magical, as though the heavens are sending a message. Yet each shooting star is something far more ordinary, tiny fragments of dust. These specks are left behind by comets as they travel through the solar system, their icy surfaces shedding trails of debris. When Earth's orbit carries us through one of these streams, the particles collide with our atmosphere at tremendous speed. In that moment, the dust burns brightly, painting the sky with a brief, glowing line. Meteor showers, like the Perseids or Leonids, repeat each year because Earth reliably crosses the same ancient trails. They are predictable events, yet they never lose their wonder. The dust itself is small, often no larger than grains of sand, yet the friction of entry transforms them into luminous arcs that vanish in seconds. To the eye, they are fleeting miracles. In truth, they are remnants of icy wanderers that once passed silently near the sun, shedding bits of themselves into space. What seems like fire falling from the heavens is instead a reminder of cycles, of comets that have traveled for millennia, of Earth's steady orbit through space, of how even dust can become light. These glowing threads connect us not just to the sky but to time itself, linking present moments with the long journeys of celestial travelers. As you let this thought rest, imagine the next shooting star you see. Instead of a wish, picture the dust of a comet burning into brightness, a trace of something ancient falling softly into Earth's atmosphere. In its brief flare, you glimpse not only beauty, but the quiet persistence of the cosmos, scattering light from the smallest fragments. When people think of planetary rings, Saturn almost always comes to mind, its bright, icy bands visible even through small telescopes. Yet Saturn is not alone. All the giant planets of our solar system, Jupiter, Uranus, and Neptune, also have rings. They are fainter, harder to see, and far less dramatic, but they circle their worlds just the same, thin halos of dust and rock drifting quietly in orbit. Jupiter's rings were first discovered by spacecraft passing close, because from Earth they are nearly invisible. Made mostly of fine dust, they scatter sunlight weakly, like a pale veil stretched around the planet. Neptune's rings are darker, formed of icy material laced with mysterious clumps called ring arcs, where particles gather more densely than in the surrounding bands. Uranus, tipped on its side, carries a system of narrow, dark rings, some sharp and well-defined, others broader and diffuse, as if painted faintly against the void. These rings are not ancient relics. They may be temporary features, sustained by collisions of moons or comets that supply fresh dust and debris. Gravity shapes them, shepherd moons sculpting edges and arcs, keeping the particles from drifting away. In this way, rings are reminders of how dynamic planetary systems remain, even after billions of years. Imagine standing on a moon of Neptune, looking back at its faint rings glowing dimly against the darkness. They would not dazzle like Saturn's, but their presence would still speak of motion, of orbits layered one within another, of time stretching onward. Rings, it seems, are not rare but natural. They are quiet signatures of the same processes that build and break moons, that scatter comets, that recycle matter in endless cycles. Saturn's brilliance may outshine the rest, but across the solar system, other worlds wear their own hidden crowns. Imagine yourself drifting in the darkness of space, watching a star reach its end. For millions of years it has burned with steady light, but when its fuel is gone, balance collapses, and the star explodes in a brilliant supernova. The violence is beyond measure, an outburst so bright it can eclipse entire galaxies. Yet if you were close enough to witness it, you would hear nothing. In the vacuum of space, there is no air to carry sound. The most violent scream of the cosmos is delivered in silence. In daily life, explosions are always accompanied by noise, thunder that shakes windows, firecrackers that echo through streets. But in space, only light and radiation mark the event. Waves of energy ripple outward, particles are hurled across billions of miles, and shock fronts shape new nebulae. Imagine the sight of gas clouds glowing in every color, spreading slowly through darkness, yet accompanied only by silence so complete it feels infinite. Astronomers detect these events not with ears but with instruments. Telescopes capture the light, while detectors record the high-energy radiation. In recent decades, gravitational wave observatories have even begun to sense the ripples these explosions send through spacetime itself. It is as though the universe does not shout but leaves behind faint signatures for us to read, quiet messages written into its fabric. The paradox of the supernova is this: it is both destruction and creation, both silence and brilliance. The elements forged in that explosion will one day seed planets, oceans, and perhaps life. When you look up at the night sky, the silence you feel is not emptiness but the echo of countless past events, stars that lived, exploded, and gave their remains to the future, all without a single sound. Imagine standing at the edge of a vast plain, able to see only as far as the horizon allows. Beyond that line, the land may stretch endlessly, but it remains hidden from your eyes. The universe, too, has such a horizon, though not of land and sky, but of light and time. Because the cosmos is expanding, galaxies far enough away move from us faster than light itself, not because they break the cosmic speed limit, but because the fabric of space between us and them grows too quickly for their light to ever reach us. Beyond this boundary lies the unseeable, a region that exists but will forever remain outside our grasp. Astronomers call this the cosmic horizon, the limit of what we can observe. To imagine it, picture light as a messenger running across an inflating field. If the ground beneath the runner stretches faster than he can advance, he never arrives. In the same way, the light from those distant galaxies is stretched away, its journey lengthened into infinity. To us, they are lost, drifting into darkness, not because they vanish, but because the rules of expansion pull them beyond reach. For humans, accustomed to landscapes that can eventually be crossed, the thought is unsettling. The night sky seems like a window onto everything, yet what we see is only a fraction of what exists. Galaxies far beyond the horizon may teem with stars, planets, perhaps even life, but their light will never meet our eyes. Imagine yourself looking upward, knowing that the universe continues endlessly, but your view is confined, as though behind a veil. And still, there is a calmness in this limit. The horizon reminds us that knowledge, like vision, has boundaries. What lies beyond may remain hidden forever, but it does not cease to exist. The universe unfolds on its own terms, stretching beyond our reach, carrying with it mysteries that will never be measured or named. In this way, the cosmic horizon is not only a boundary of sight, but also an invitation to wonder at the immensity that forever lies just out of view. Imagine yourself looking up at the night sky, countless stars scattered across the dark canvas. Each one feels steady, eternal, but the universe itself has a fate waiting beyond imagination. The truth is, we do not know how it will end. Physicists suggest several possibilities, each both profound and unsettling. One idea is the heat death. As galaxies drift apart and stars burn out, the universe will cool into silence, every particle spread so thin that nothing more can happen. Another theory is the Big Rip, where the force of expansion grows so strong that galaxies, stars, planets, even atoms are torn apart, unraveling reality itself. There is also the possibility of a cosmic bounce, in which the universe contracts after expansion, collapsing inward before exploding outward once more, an endless cycle of death and rebirth. The evidence we have today hints at an accelerating expansion, but the future remains uncertain. Ancient starlight, faint radiation from the Big Bang, and the movement of galaxies act as faint clues in a puzzle too vast for us to complete. Each theory reflects not just physics, but also our human desire to understand endings, to know how stories close. For ancient cultures, the universe was imagined to end in fire, flood, or divine renewal. Our modern ideas are shaped by equations and telescopes, yet they carry the same longing, to bring order to the unknowable. For daily life, the question feels distant. We still plant crops, mark calendars, and fall asleep under the stars. But somewhere in the quiet rhythm of existence lies the knowledge that all of this, every clock, every sunrise, every breath, unfolds within a universe whose end remains unknown. Perhaps that uncertainty is not frightening but gentle, reminding us that life is lived not in the conclusion, but in the mystery between beginnings and endings.